All right.
Alex?
Yes.
Yes.
All right. So good morning again, dear faculty members and other panel members. Happy that we are stepping into the third day of the faculty development program, which is sponsored by AICTE-ATAL and organized by Department of Electronics and Communication Engineering of Karunya Institute of Technology and Sciences. So first of all, I would like to invite Dr. K. Martin Sagayam for briefing about today's schedule. Please, sir.
Yeah. Good morning to one and all gathered here. So I welcome Professor Sridevi ma'am from NIT Trichy. I welcome for the third day of AICT sponsored ATAL FDP program on roles of augmented reality and virtual reality in real-time applications. It's my immense pleasure to say about the valuable content of today's session. So at 9 a.m. to 11 a.m., we're going to see on the topic elements in AR, EMR, etc. about the haptic tracking and visual perception. At 11:30 a.m. to 1:30 p.m., we're going to see on the topic experiencing, collaborating, and usage of augmented reality. And at the third session, 2:30 p.m. to 4:30 p.m., we're going to see on the topic demonstration on Unity 3D software, working of the 3D game object in Unity and VR in Unity. So it will be really useful for you. Be safe and thank you. Now I hand over to Alex Matthew for introductory section of session speaker.
Thank you, sir. As we said, we have got our eminent speaker for today's FDP session, and she will be handling a session on elements on AR, VR, MR, XR, haptics, tracking, and visual perception. Thank you, ma'am, for being with us. A brief introduction for the faculty members. She has got her Bachelor of Engineering in IT and Master of Engineering in Computer Science and Engineering and PhD in Computer Science and Engineering. She's in the capacity of Assistant Professor in Department of Computer Science Engineering in National Institute of Technology, Trichy. And her areas of interest include parallel processing, computer vision and image processing, soft computing, system software, machine and deep learning. Thank you, Bam, for being with us. And she has been a teacher from the year 2006. So I think we will be getting much benefited by her today's lecture. And we are really happy that ma'am is here. Thank you, ma'am, for being here, and welcome you all. Thank you.
Yeah, thank you very much, sir. Thank you for the introduction. So I thank the organizers for inviting me for the lecture. Let me share my screen.
Yes.
I think you can able to view my screen.
Not yet, ma'am.
Not yet. 1 minute.
Yeah.
Let me.
Yes, ma'am. Now it's perfect.
Yes, sir. Thank you. So today in this session, good morning to one and all present here. So probably you might have undergone different techniques and methods and what is an AR, VR, MR, XR, everything has been discussed in last 2 days with some hands-on experiences. So this session, mainly we are dealing with the elements which is present in VR, AR, MR and XR haptics and how the tracking is performed and how the visualization is performed. All this concept will be discussed in this session. So let me close my uh, video so that it is convenient for me to discuss. So I will be talking about all these things what it is listed here. Today's lecture mainly I'm focusing on just a brief of a VR, AR, MR and XR. As you know already, just I will explain you a few content related to this, and then I will move on to the reality, what is in reality and what is in virtual reality, what is the difference between these two things, how we can make a virtual reality. That will be the topic we will be discussing in the few slides. And then the main motive of today's lecture is then element which is resides in AR, VR, MR and XR. All those things we will be discussing, and along with how the tracking and haptics are used, and visual representation and perspection will also be discussed. I have a couple of videos with me to explain the concept that will be very useful to you. So rather explaining a theoretical concept, if I show some video, that will be very useful for you to listen. So I thought I will be showing some more videos. I have 10 to 11 videos with me. Each will be less than 1 minute to have a feel of what is that particular content. So all this information, whatever images and video, whatever I am using, it is taken from the internet source, YouTube and Google only. So I just wanted to say that here. So I will be moving on to the content right now. Uh, as I said, we are going to discuss AR, VR, MR, XR. So for making a reality technology, whatever virtual reality technology we are going to use, that required some devices. So some of the devices are listed here with respect to VR, AR and MR technologies. So we will be discussing this in our forthcoming slides. That just to have an idea, I have thrown the slide here. Now coming to the uh, VR, AR, MR and XR. Let me show a video and then I can go to my lecture. Uh, I think you can able to see my screen. Can you able to see the video?
Yes.
Yeah.
Yes, ma'am. Yes, ma'am.
Yeah. Thank you, sir. So in the case of an AR, augmented reality, you can see a person is dancing in a background. So you can have a feel that the background or whatever the real object that can resides there, and you can impose an digital object onto that. That is called an augmented reality. In the case of virtual reality, the person will be fully immersed into a digital technology. You will be in an virtual world. Nothing will be related to your real world. So example is given here with a 360-degree rotation view. A person is viewing with a camera in a 360-degree rotation to get the feel of the virtual reality. Next comes the mixed reality. It's a combination of augmented and the virtual reality. So some the digital and the real world object coexist between each other. So a video which is explaining the both the digital object, you can see the digital objects and the real object exist between these two things. And in the case of an extended reality, it's an umbrella which has all the three kinds of reality, whatever example we have discussed right now, which consists of an augmented reality, virtual reality, and a mixed reality. So I am moving back to the slide. As it was explained here with respect to the video, now it will be very clear to you what is an augmented reality. Already it was clear to you. Just to make a brief on AR, VR, I have given you the example and the videos. So you can see you have a background, you can see it's a real-time video, real-time object. So you are trying to imposed some are trying to use some of the digital object. This digital object is imposed into this. So to perform this, you required some devices. Now mobile phone and tablets are the popular device which uses an augmented reality technique. The popular example for AR is an Pokemon Go game. So again, I will be sharing a small video for this to get a feel of how it is done. Am I audible?
Yes, ma'am, you are audible.
It's taking long time. I thought some problem in my internet connection. Sorry, sir. Okay. So you can see a person. This is a real objects, and they are trying to put a virtual object or a digital object onto the thing. So by making use of this, you can create an augmented reality. This is mainly useful in the case of game technologies. So a simple game is given here for doing this. So you can see a person is having his mobile phone. With this, he is trying to do the augmented reality. He's trying to play a game on it. Next comes an VR, virtual reality. As I told, it's an immersive experience. Only the computer generated reality you can see. There is no reality will be there. All the objects will be in virtual objects. So you are trying to make an virtual reality effect by using some devices. So the example video for this VR is I think some issues in playing the video. So let me come back to the video later. And next comes an, I have another example for a VR. At the end, I will show that example too. So next comes an EMR. It's an mixed reality. It is a combination of both augmented and the virtual reality. It merges the real and virtual world object to produce the final reality concept to you. So again, I have another example for MR. At the end, I can show you. Now I will be moving on to XR. As I told, it's an mixture of all the three realities, that is augmented reality, virtual reality, and mixed reality. So it's a extended reality. It's mainly what is then applications and where you can use this extended reality. So we can use this and again showing a video which shows the application where we can use this XR, that is extended reality. So it has different different application where you can use this. So you can see the different application where it is used. And also I will be explaining about what is the challenges which is there in XR. I think it's buffering. It takes some time for display. So for making all these things, you need a set of devices. It can be a head-mounted devices or a sunglasses or something. So all those things we will be discussing in the forthcoming slides. So I'm not sure why it's taking such a time to display. Anyway, now coming to the reality and the virtual reality. So we will discuss what is on reality and how this reality is related to a virtual reality. When you talk about on any reality, we can understand the world through of some sense. Either the sense can be seeing, hearing, touching, tasting, or smelling. These are all the five sense organs that we have. Based on this, we can use and we can find out what is going inside the thing. So for this, two basic processes are there. One is an sensation and perception. The sensations are gathering the information and the perceptions are interrupting the information. Once you gather the information, how you are going to react for that. A diagram which shows the reality and the virtual reality. So this diagram will easily explain you what is the difference between reality and the virtual reality. If it is in reality, as I told you, the senses will be, I mean, based on the sense, you can find out the action. So the reality, you have sense, and based on the sense, you will gather the information and you will act based on the information. So this will be the process in the case of reality. When it comes to an virtual reality, so you need a special devices, as I told you. The devices may be the two devices we required for this purpose. One is an input, another one is an output devices. This will be between the human perception and the action. So before taking into an action, this two devices between the human perception and the action, these two devices will be kept and you will get the feel of virtual reality. And the how this senses are stimulated in the case of a technology. So with respect to reality, virtual reality, how this is performed. So you can see here we have a network here. So it will send some simulations. The simulation can be either a sound, vision, or it can be any speech, or it can be an physical simulation. Anything can be here. As I told you, five senses. Based on this can be stimulated from a network, and then this will be passed to an human machine interface. The machine which supports for sound as the headphones, and for which vision it uses an um, glasses or head mounted devices. And for physical sensations, we have some trackers, and for speech you can speak via mic. So for making an interaction between this device with the acquired simulation system, there required some drivers. The drivers will connect these things, and finally you can able to get the output as an audio or a vision or a haptic or a speech. All these things can be obtained as a result of this. Finally that can be interrupted into the human brain. Now this whatever the process we have discussed right now is used with a simple example of visual simulation. It is explained here. You are getting an visual simulation. So from the visual simulation, it is converted into an 3D graphics, and based on the device what we have with the HMD device, which is an head mounted device, and finally it is going to give an vision. That vision the person can view from the vision system. So this is the way by which the process is going to take place. And coming to the reality and virtual reality, Milgram developed a continuum, which is a virtual reality continuum. The continuum says that the augmented reality to identify the system which are mostly synthetic with some real world imaginary added, such as texture mapping video onto the real objects. So virtual objects, you have a real object, you are adding something onto the real object with the help of some virtual objects. So we have a real environment and a virtual environment. This generates an augmented reality, and this generate an virtual reality. When you use these two things, virtual and the augmented, you will be getting a mixed reality. So when combining the real and virtual objects, what you have to keep in mind, what are all the steps or what are all the important things that we need to have in the mind. First, the location, and you should have a precise model, and then you should, second is you have to have a location and the optical property of a viewer and the display. The location should be properly placed. You should correctly, the calibration of all the devices should be taken care. To combine all the local coordinates, I will be discussing about these coordinates, different coordinates we have. Those coordinate system I will be discussing later. So we need to combine all the local coordinate center onto the device and the objects in the screen in a global coordinates, and then register the model of all the 3D objects. And finally, we can track the object over time when the user moves and interact with the screen. So the main thing is you have to fix the proper coordinates, and then you have to track all the objects throughout the screen. So these are all the main thing we are going to discuss in the forthcoming slides. How these things are going to be happen with the help of some devices. As I told, in the case of virtual reality, you require input and output devices. With the help of those devices, how these operations are going to be taken place, that is the main thing we are going to discuss in this throughout this lecture. The realistic merging, when you merge the realistic object into the virtual object, what are all the requirements that you should keep in mind? The object should be, whatever object you are taking, that should be give you and reality feel that it is it doesn't show you that it is manipulated from some digital object. It should show you a reality, and there should not be any occlusions when you are tracking, and the shadow should not be there. All this requirements you have to, and also there should not be, and when you talk about occlusion, also the collision will come. When an object is occluded, the collision may occur. So all this should be keep in mind while you merge the reality with the virtual reality. We are going to discuss on different types of reality: AR, VR, MR, and XR. Now we are moving on to the main content, that is the elements which is used in all these devices we are going to discuss right now. Now coming to the working of an augmented reality, AR. First, it will capture the image or a video sequence, and it will try to embed the object, which digital object what you wanted to embed onto it. Finally, it will give you an output as an augmented reality output. So what are all the components are required for performing this? So you need a set of hardware, software, and a dedicated server for performing this operation. So what kind of hardware is required? We have already discussed. It requires a set of input and output devices. So we need input and output devices. And what kind of software is required? So we are making an 3D graph. I mean, in the previous diagram itself, I told you we are trying to make out an 3D graphics. So the software related to those things can be used as a software, and a server which is going to perform this main task, whatever we are going to perform. So what are all the steps which is involved in the case of when you perform the operations? So this diagram will show the flow of how it is performed. First, from the input device. The input device can be either a camera or a GPS accelerometer or a whatever input device you want, you can use it. The input device will capture the real scenery or a real content. This captures, the camera captures the real scene, and this is given to the processor for processing. So the processor will send the request to the web server. The server, what it is requesting it requires some virtual objects. So the virtual object will be sent back to the processor by the server, and once the real content and virtual content are there, they are augmented and sent to an AR application. So the software will merge these two things, and finally it is going to be displayed in the display devices. The display devices can be anything. It can be a head mounted display or a smartphones or eye glasses or whatever the display can be. Finally, it will give the display augmented content to a display device for displaying. So now the camera input device, it's capturing a real world object. It is given to the hardware and the software part for making an virtual object and making an augmented content into the real world, and finally it is producing an output that can be viewed in an display devices. Here the screen, now smartphone screen is used as a display device for displaying the corresponding augmented content. So you can see here some things are augmented with a real scenario or say real objects. Next comes on display devices, because our main motto is we are not talking about other things. Only main motto is to talk about on display devices, which is an output devices. So when in the case of an AR, we have two types of devices, which is an output devices. They are monitor based device and head mounted devices, HMD. So head mounted displays or devices we are going to use. So in the case of monitor based devices, you can have a laptop or a mobile phone screens or a projector to project the final output. And in the case of head mounted display, we have two techniques. One is an video seen through and another one is an optic seen through. We are discussing about these three categories and how they are working and what is the advantage of those techniques. The monitor based augmented reality, you can see the simple configuration of a monitor based augmented reality. So the real scene is captured via camera and it is converted into an given to an graphic system for converting into an virtual object, and finally you are merging the virtual object with a real scene, and finally it is given to the augmented video is given to the output devices. The output devices here we have used as a monitor. The main advantage of monitor-based augmented reality, the three main advantages: the customer level equipment. It is easy to, no special equipment is required for this, and it is used most practically. So a lot of researchers are mainly focusing on monitor-based augmented reality. And the second category is an head-mounted displays. There are two different categories, as I told you earlier. One is an video scene, another one is an optic scene. In the case of a video scene, the execution or the flow of a video seen through HMD, how it is, the person is here, he is having a device. The example device is given here. He is having a device, he is wearing that head mounted display devices. So a camera is there that will capture the real-time scenario, and it will be given to an video comparator, and this head tracker will generate a scene, and this will be given here. And finally the video, combined video with an real world and an virtual world will be added into it, and final video will be given back to this monitor, by which the person can view through the device itself. The advantage is it's flexible, and real and virtual views delay can be matched. That is the main advantage of using video scene. And optic scene through HMD, in the case of this, it has the example optic scene device is given here. So the device has head tracker. So it has, you can see it has an camera that gathers the real world object, and the scenes are generated with the help of an head tracker, and finally it will be merged and it will be given as an optical combiner. So optically through an eye you are seeing the real world, and it is mixed with an virtual objects, and finally you can get an optical scene. So as I told, everywhere here we are using a tracker and also we will discuss about the tracker, how it is performing. In the case of an augmented reality, we have a concept of called tracking. So you have an uh, the display devices and some input is there. The camera is capturing the input. If this is an input device, it captures the input. It is trying to form a video tracking and 3D processing, rendering, animation, and then it is trying to superimpose the given object into the 3D display. Finally, you can see the augmented reality on that. So how that tracking is performed? There are different ways by which we can perform and tracking. Whatever tracking concept we are discussing, it's suitable for both AR and VR. In the case of augmented and virtual reality, the trackings are used. So this will be suitable in both the cases. We have indoor environment and outdoor environment, and there are some toolkits are available. Some devices are available for each and every category. So this is the main thing related to tracking. And what are the different types of trackings are available? Basically, the 5 different trackers are there. One is a magnetic tracker, inertial tracker, ultrasonic tracker, optical tracker, and mechanical tracker. And further, it is classified into different categories. So we will discuss each and every category, and then we will move on to the remaining portions. So I have mainly the optical trackers are explained here. Other 4 trackers are not detailedly explained in the slide. I'll explain you orally how this is performing, what is the idea behind each and every tracker. In the case of a magnetic tracker, the difference between a magnetic transmitter and a receiver is captured. Based on that difference, it is performing the operation. In the case of an inertial tracker, it is measuring a linear and angular orientation rate, and then it is performing the tracking operation. Ultrasonic tracker, the time of flight or a phase coherent sound waves. Based on the sound waves, it is making a tracking. In the case of a mechanical tracker, mechanical arms with joint sensors are used for tracking purpose. And now I will be coming on to the optical tracker. So optical tracker further classified into 3 categories: specialized tracking, marker-based tracking, markerless tracking. And in the case of markerless tracking, edge-based tracking, template-based tracking, and interest point trackings are exist. So in the case of an optical tracker, the idea behind this optical tracker is it uses an image processing and computer vision concept. So some of the tracking devices are given here. For example, there are 2 categories we have. One is an outside in and another one is an inside out tracking. So I will come back to this tracking. I will explain how this outside in tracking and inside out trackings are performed. So in the case of an outside in tracking, we have an headset, and the accelerators are tracked by some external devices. The headsets and the accessories, the headsets and the accessories are tracked by an external devices. So this is an headset you have, and you have a something, some camera or sensors or something is mounted here. So the headsets and the accessories are tracked by an external devices. So the camera is placed in a room. If you consider you have a room, in the scenario of room, different cameras are placed in the room, and determines the positions of the headset in relation to its environment, and then based on that the tracking is going to be performed. So here the cameras are fixed. It can be a camera or any other external devices. It can be a sensor or something. So for example, the cameras are mounted in a room and a person is wearing a headset. The camera is fixed and the person is trying to move here and there. The camera is placed in the room and determine the positions of the headset in relation to its environment. Based on that, tracking is going to be performed. And what is the advantage of this kind of outside in tracking? So in the main advantages, this is fixed and it will give you one best accuracy. So to get a more accuracy, you need to include more trackers. And the main disadvantage is there may be a problem of occlusion. I have already given you the requirements for a virtual reality merging, occlusion, collision detection, shadows, and whatever the object you are producing, that should be a realistic object. These are all the main requirements I have already listed out. The main disadvantage of outside in tracking is occlusion. The sensor need to be able to track effectively in 360-degree, else they lose the placement of the moment you turn around and in and around. So when you move in and around, there is a possibility of losing some of the screens. So reality may be lost here. If you go out of the region, something, if you step outside, then the space of immersion may dry, so the tracking may be lost. That will be the problem in the case of outside in tracking. In the case of inside out tracking, the camera is placed on the device. In the device itself, the camera is placed in the device during tracking and looks out to determine how its position is changing in relation to the external environment. So the main thing here is the camera is placed on the device itself, and it is tracking and looking to determine how the position is changing in relation to the external environment. As headset moves, the sensor re-coordinates its place in the room and giving an immersion that you are moving through the virtual environment. This is in the case of an we were discussing about the different categories. So the of optical tracking, the other category is a marker based tracking. In the case of marker based tracking, how the markers are used to track the object, you have an video streams which is captured from the camera. You try to search for the marker. The image is converted into one binary image and the black marker frame is identified. So based on this, you have identified the markers. After identifying the markers, we have to find the markers 3D position and the orientations. So for the positions and the orientations of markers relative to the camera are calculated. After calculation, identify the marker. The markers are identified and this is given into the positions and the object orientations are given, and whatever the virtual object you wanted to embed on this, that will be given as an here. So this is the input sequence. From the input sequence, you are trying to embed this into this. So for this, you are using a technique called a marker. You are just finding out the position where you wanted to keep this, and then you are based on this region, you are trying to make a tracking. So the main challenges in the case of tracking, so in the taxonomy, I have told that the tracking in the indoor scenario uses AR toolkit. So the disadvantage or limitations of AR toolkits are given here. The main disadvantage or the limitations are occlusions. So occlusion is then one thing. If the object is occluded, whatever the marker you have, it is occluded, then it is difficult to identify. And blurring effect is there, and also that will cause us an problem in the case of tracking. Uh, dark or screen, or how based on the lighting condition. The lighting condition is also making a problem. So the markers need to be identified properly. It should not, it should be free from occlusions, blurring, noise, jitter, and also its lighting effect should be proper so that you can get a proper view. Next comes on VR. In the case of AR, we have discussed how it is performing and what are all the categories we have. And the third category here is markerless tracking. In the case of markerless tracking, we have three different categories: edge-based tracking, template, and the interest point. In the case of edge-based tracking, object is there. You have to find out the edges which is resides in the object, and based on the edges you can track. Or a position can be, the template can be matched, and based on the template you can track. Or you can find out the interest point in the image, and then based on the only interest point you can track. Next comes an virtual reality. The elements in virtual reality. So for virtual reality, again, we required some special kind of devices. So some of the devices are given here. The main difference between the augmented reality and the virtual reality: in the case of augmented reality, the system augments the real world scenario. But in the case of a virtual reality, it's immersive environment. It is totally a different environment. Everything is related to an virtual virtual world. And the second difference is the user maintains a scene of presence in a real world. In the case of virtual reality, the senses are under the control of system. And in the case of an augmented reality, needs a mechanism to combine virtual and the real objects, needs a mechanism to feed the virtual world to the user. Hard to register real and virtual, hard to make VR world interesting. So the main challenges is it's very difficult to make a real and a virtual object. And also in the case of VR, you should try to make an interesting VR world. That is a main challenge resides in both the cases. Now coming to the components of VR system, the VR system consists of similar to the previous case, it consists of an processes and simulation processes, input processes, and rendering processes with some real world database. We will explain how those displays are going to be. Now, we have discussed some, we have saw some of the VR devices. So we will discuss how they are categorized. Basically, the virtual reality displays are classified into two. One is in basic and enhanced. In the case of basic, it has hand-based, monitor-based, whereas in the case of an enhanced, it has an partially and fully immersive. In the case of partially, you can project it on wall projectors, immersion desk, and monocular head-based. Fully immersive, room-based, and bi-monocular head-based are the basic classification. Again, room-based is classified into vehicle simulation and K. What are all the steps involved in the case of VR? As we have discussed the steps involved in the case of an AR. Similarly, we are trying to discuss the steps which are involved in VR. The first step here is, so we need to define what we are going to obtain. The objective should be defined first, and then select the objectives that can use the simulator or VR for measuring or attainment. So what kind of simulations we are going to use, what are all the objects required, everything you need to, the requirement should be selected based on the objective, and then refine the selection, choosing those that can be used in 3D simulation. Now whatever you have selected, that is now we are trying to make out with this 3D simulation. if required, refine those selection. If something is required, you can refine it and perform these steps. Determine the level of realism, type type of immersion and the presence, and type of interaction and sensory outputs. These are all the three things we need to determine. And after determining this, choose a VR software to perform a real world environment. So after choosing it, real world VR hardware, software, and the output devices, then you can give design those things and build a real world environment. Finally, you can able to evaluate the virtual environment with a pilot group. Finally, you can modify if required. The steps can be modified. If it is not into one realistic, you can modify that. And in the case after this, you can, if it is satisfied, then you can move on to the next step. Evaluate the virtual environment with the target populations. And finally, you can modify the results of evaluation based on uh, the output. So you can repeat a step 9 and 10 if it is required. Now, this simple diagram will explains you how the process is taking place. You have an input data stream, and the input data streams are obtained from the device that is holded here. One is in 3D mouse, another one is in tracker. So the input streams are tracked from this, and we are going to process this in the hardwares we are using here. We are going to process this in the software, and finally it is going to given us an output in the case of an display devices. This will be our display devices. Finally, you can get the output. For performing this, as I told you, these are all the steps these are all the things we are performing. To performing this, these are all the steps we have used. So capture the inputs and perform the operations. After performing it, and try to make a virtual world, build the virtual world with the help of a software, and then it can be given to a display devices for display for the corresponding user. Now we are trying to map the input and the output. So you have a VR user, the person is here. We have a set of inputs and a set of outputs. So from this diagram, you know that you have a inputs and the output. Both will be with the help of this user only. You are using this. So the VR users are here. He is trying to get some outputs from the computer, and he is again seeing the outputs in the device. So he is trying to give some inputs. The inputs will be given into the computer for processing. This is the expanded, the diagram is expanded and it is explaining how it is performed here. So in this, with respect to input and output devices, we are talking about what are all the kinds of hardware input and the output devices we can use in the case of VR. So VR input devices, hand input devices. There are different hand input devices we have. Devices that integrate hand input to VR are called hand input devices. The world grounded input devices, non-tracked handheld controller, tracker handheld controller, hand warm devices, bare hand inputs, or these are all the inputs we have. So out of which we have already, you are familiar with some of these devices, that is joystick, Xbox controller, Y controller, all these things. Maybe these two are very familiar to you. It talks about a degree of freedom. I will be explaining what is a degree of freedom after a few slides. So when you are using games, when you are playing games, in those games we will use an Xbox controller or a joystick to control the screen objects. So these are used, and some non-hand input devices are also used for this purpose, for getting the inputs. That is head tracker, eye tracker, microphones, full body trackers. So different trackers. This captures the input from the other part of the body. Instead of hand, it will try to capture the input from other part of the body. So the head, eye microphone or full body trackers are used. Some of the output devices are given here. So once the inputs are captured, it will be given to the system, and the system will produce the output to the display devices. The few output devices are displayed here. This can, some are displayed to you. Now we will discuss what is the degree of freedom. The 3 degree of freedom and 6 degree of freedom are there. So when you are making our tracking, we should keep in mind of the degree of freedom. So in the case of 3 degree of freedom, it is related to orientation. Another 3 degree of freedom is related to translation. So I think you were aware of what is translation and what is orientation. In the case of translation, if an object is in this position, if he is trying to move either in X direction or Y direction or Z direction, you can call that as in translation. In the case of rotation, if the object is rotating about X axis or Y axis or Z axis, then you can call that as in orientations. So for performing this, what is 3 degree and 6 degree, I'll show you another video which explains you clearly how this degrees are explained. So the degrees are with respect to X, Y, and Z axis. If a person is rotating either in X, Y, and Z direction, so he's wearing the headsets. Now he is moving in X axis, moving in Y axis, moving his head in Z axis. So again, in the case of another 3 more degrees, the person is trying to translating, previously rotating, now he is translating in X axis, Y axis, and Z axis. So the first 3 degree is with respect to the orientations, how he is rotating, whether with respect to X, Y, or Z axis. The other 3 is with respect to translation, whether he is moving in X direction or Y direction or an Z direction. Based on this, the 3 degrees are given here. So if a system has the rotation and also the translations, then it is, as you can say that as an 6 degree of freedom. Now, as we have discussed some trackings techniques in AR, there's some more trackings techniques we are going to discuss with respect to VR also. All the trackings, whatever we have discussed in AR, that is maybe used in VR also. So what is the need for tracking? The user turns their head and the VR graphic screen changes. Now you can see the person is wearing some devices. So he has one device here, another device here. These are all the hand tracking devices. This is an head tracking devices. So now what is the need for this tracking? The user turns their head. What will happen now? If he turns it, automatically the scene may change. The user wants to walk through the virtual screen. So when he is moving onto the screen, and all, for that it requires a tracking. The user reach out and grab a virtual object. There you need a tracking. The user want to use an real proportion in VR, there also you need a VR tracking. So the main need for tracking us, this is the main need why we need to use a tracking. All of this requires a technology to track the object or the user. So continuously provide the information about the position and the orientations. So while tracking, it needs to continuously process the orientation and the tracking. Different tracking technologies are, there are three different technologies: active, passive, and hybrid technology. In the case of an active technology, already we have discussed, in the case of an AI taxonomy, we have discussed different tracking systems, 5 different tracking systems. So those are tracking system: mechanical, magnetic, and ultrasonic, and passive, inertia, and computer based, that is optical systems. In the case of hybrid tracking, it uses a combination of this to get this. So now I will be discussing the advantage and the disadvantage of each and every tracking system. Why this is advantages or why it is disadvantage. In the case of a mechanical tracker, the idea behind the mechanical tracker is it uses in mechanical arms with joint sensors. The main advantage is here, it gives a high accuracy. The main disadvantage is it is expensive, very expensive. That is the main disadvantage of this. In the case of magnetic tracker, difference between a magnetic transmitter and a receiver is captured. That is the main idea behind this. The main advantage of this magnetic tracker is it uses 6 degrees of freedom. So it uses 6 degrees of freedom, which means it can able to handle the rotations. 3 degree of 3 axis of rotation and 3 axis of translations can be possible here, and the system is very robust. And when it comes to the disadvantage of a magnetic tracker, it's wired, so it is expansive, and also it is sensible to the metal and noise. So these are all the disadvantages which resides in the case of magnetic tracker. Ultrasonic tracker, already the idea behind this we have discussed. It uses a phase coherence and the sound waves. Based on the sound waves, it is trying to produce the tracking system. The advantages, it's very cheap, but the disadvantages, it will handle only 3 degrees of freedom. So it is not able to handle the other trackings. Only 3 degree it can handle. That is the main disadvantage of the system. In the case of an passive system, passive tracking system, so inertial trackers, which uses an idea of measuring linear and angular orientations. So the main advantage is it's cheap, small, and also it's in wireless. Uh, the main disadvantage is there is no transmitters are used here. You can see here the active system device sense and output signal, device sense and world details. So there is no transmitters are required in the case of an passive. That is one advantage. The disadvantage of the system is, again, it uses in 3 degrees of freedom, so it is very difficult to use. When it comes to an vision system, which is an optical based tracker, it uses an computer vision and an image processing concepts. It is a very small, and it is mainly useful because it has the degree of freedom, full degree of freedom. And later it comes to an hybrid tracking. In the case of an hybrid tracking, it uses the combined sensors. Either it can uses the combinations of anything, and finally you can able to get the tracker output. When you are performing and tracking, the head or the body motion need to be captured, and the sensors and the sensor fusions are given into the rendering to make a rendering of the content. After rendering, the image display will be given to the human for visualization. And there are different coordinates that we need to discuss about the tracking. When we are using our tracking, there are several coordinates frames to be considered. So what are all the frames we need to consider here? First coordinates is head pose with respect to a real world. So in which direction you are facing, the corresponding coordinate value, the head pose with position with our head pose with respect to the real world, and the coordinate frame, it's frame, coordinate frame of tracking system with respect to the head mounted display is the second coordinate. Position of hand in coordinate frame of hand trackers are to be identified. So you have an hand motion tracker and you are trying to find out how the different coordinates, I will be talking about the different coordinates with the examples. Now let us have how we are making this in the case of, and now you have a head motion tracking camera. Now you are trying to find out your hand in an VR. So how this is used? So it uses the lighthouse and leap motion thing. The multiple coordinate frames we have used is the leap motion tracks hand, which uses the coordinate as HLM, and the leap motion as fixed in the HMD coordinate frame. So the second coordinate is this. And finally, this will be is tracked in a real world frame. So this is your real world frame. So now combine the transformation in each coordinate, you will get an real world coordinate. So after combining all these things, you can able to get the real world coordinate frame. So previously we have discussed three different types of coordinates. With a simple example, here we have find out the real world coordinate frame, and a simple video is also there that explains how this is performed. So the person is holding a head mounted device, and he is trying to move this. You can able to see how the effect when he rotates or when he translate, you can see the effects on the display device. Now the objects are he is trying to move here and there, so he can able to show with this example how the position tracking is performed. So when this is moving, you can easily track out the objects in your screen. And another video, which is, there are two another videos, which is one is for full body tracking, another one which is demonstrates how the Cybernet is giving a demo on visualization. 2 more videos is there to know more about the tracking. So this is the full body tracker. You can see the person has different sensors or something. Based on this, the tracking is performed. So you can see how it is visualized. So they have different sensors by which the full body can be tracked. When a movement act takes place, it will track. And you can see how the virtual aid is displayed. So another video which explains about visualization. So you can see a person is wearing and he is trying to perform some actions here. So that in the camera he can able to see this. When he moves here and there, he can able to move on the virtual reality environment. Either he can move in this direction or backward. Another one is rotations. So the example will clearly say how he is moving upward, downwards, and he is moving here and there in a real world scenario. So next comes in augmented reality. So as of now, we have discussed 2 kinds of reality. One is in virtual reality, other one is in uh, augmented reality. Now we are moving on to one next level of reality, which is a mixed reality. So earlier we have discussed with respect to one reality, reality virtual continuum. It says that you have a real environment, it generates a real argument. You have a virtual environment which generates an augmented reality. Mixing of these 2 reality will gives you a mixed reality concept. So how this is going to be taken place. Now the real environment is appended and you will get an augmented reality. Virtual environment is there, you are getting an augmented virtuality. And finally these 2 are mixed to get a mixed reality. What is the difference between these 3 realities? So you can see here in the case of a virtual reality, here you have the completely a digital environment. Full of the person, whoever is using a virtual reality, he's fully in a digital environment. He's immersed into a digital environment. He's not don't have a control about the real world object. Entire thing will be simulated, computer simulated environment. It's fully enclosed, synthesized uh, experience with no sense of real world. In the case of an augmented reality, the real world with the digital information is overlaid onto it. The real world remains center and to experience the enhanced by virtual details. So I have given you examples also. Now in the case of an education and all, nowadays they have used an augmented reality. Probably you might came across with some of the examples in the case of an augmented reality. Suppose in the case of an marketing, this is the best example I can give. Suppose you wanted to buy a sofa or something to your house. You can take your uh, place, capture your real world object where you are going to keep this sofa. You can embed it and you can see how it looks like. Based on that, you can decide what kind of model you can select. That will be very much useful in the case of augmented reality. And when it comes to an mixed or the merged reality, it uses an real and virtual reality concepts. It interact with and manipulate both the physical and virtual environment. It creates both physical and the virtual environment. So the differences are the same thing as given here with the differences. And coming to the working of an mixed reality, how that mixed reality is going to work. You have a real world a virtual object. This is in virtual object, real world data from the sensor you are capturing. So you are trying to get the real world data, and you are trying to get the visual you are trying to get it from a sensor and visual data from the real world, and this will be given to video in the trackers. Excuse me, 1 minute. Yes. So the real world objects are in the video in. Now the processing unit is there. That processing unit is trying to mix up these two informations, and you will get a visual unit here and you will get an real world unit here. Those two will be mixed by using some softwares, and you will get a mixed reality. The virtual content will be given as an output in an output video. So for performing this, you required some computer vision and image processing concepts to do this. The example for an MR, so you can see this example, it's an best example. You have an camera, the camera is and you have a position tracker. The tracker will give the value, some information to the system, and the camera will capture the real world scene. This will be combined, and finally it will be given to a display to make a mixed reality display. There are two types of displays that uses a mixed reality experience: holographic device and immersive devices. So this is an holographic device and this is an immersive device. The example is HoloLens, and this is an Samsung HMD. So in the case of an holographic device, the devices are characterized by the device's ability to place digital content in real world as if they are there. In the case of an immersive device, they are characterized by the device ability to create a sense of presence, hiding the real world and replacing it with a digital experience. So these are the two examples. They uses a 6 degree of freedom, both rotation and translation. 3 degree with respect to rotation and 3 degree with respect to translations are used here. And next comes the extended reality. So in the case of extended reality, it's a mixture of these three reality. It's an umbrella for all the immersive technology. The difference between VR, AR, and XR. So we have already discussed the virtual reality and augmented reality plenty of times. Now we will say what is XR. The XR is an extended reality. The technology immerses the user through visual, audio, and potential of olfactory and haptic cubes. There are two major types of XRs are virtual reality and augmented reality. The main challenges which is resides in the case of XR technology, I will be showing on video which will explains the challenges. I think it's not opening. Yes. So previously I have explaining this, the examples of example application where you can use XR. Already I have showed this examples. It is useful in many applications. So in play games, you can use it for physically disabled people. This can be used fitness, working professionals, and tourism. Everywhere you can use this XR technology. So some of the devices that can be used in the case of XR, it uses the devices which is used in AR, VR, MR. So some examples of AR and VR mounted, head mounted devices are shown here. Coming to the challenges, so the device with explanations are given here. Coming to the challenges, what are all the main challenges? The device should be very simple, and also it should be very handy, and it should not be a very heavy weight, and the cost should be very affordable cost, and high computing requirement. It should compute in and faster, and latency should be avoided. So these are all the main requirements. Now coming to the factors. So you can see the different devices in the challenges, which says that it should be small and cost should be very least. So the challenges that it is displaying here are it should be affordable, and also it should be very thin to use it. And computation, while using a computation, because it requires computation as power is required for computing, for adding those sceneries and all, it should have an better computation power. So obviously GPUs are required. And in the case of latency, the latency should be keep in consideration so that you can get to the real world scenario as expected. So we have discussed the elements of AR, VR, and MR, and then all those uses and concept called it requires some input devices and output devices or a display devices. In between it requires a processor. So it requires a hardware, software, and intermediate it uses an processor system for computing these purposes. After performing all these things, we have discussed it while you make a virtual reality environment, it requires a tracking. Based on the tracker only, it is going to perform the operations. So now we are moving on to the another part called haptics, which is used. It is a technology. By adding the sensation of touch and feel to the computer, you can able to get a VR scenes. So how this is going to be performed. So now we will be moving on to this part. So with this, while you touch or you when you touch, it has to the connection should be there. Touch as we discussed, there are 5 senses. So based on that, we are going to discuss how human will react and how the machine will react with respect to the touch. So when you have an virtual object here, you have a virtual objects. So the first, the hand is touching this. What it will do, it will make a sense, and the brain will make the activation, and it will pass the information to the make a corresponding action. So first diagram we have discussed with how reality and the virtual reality is taking place. Similarly, you can correlate that with this. Now, when you touch the virtual object, it will, when you touch the normal hand, what will be the reaction you will be getting? When you touch the virtual object, what will be the reaction which will be obtained in the computer? So the computer will sense it, and then the position informations, everything will be tracked, and based on that, it will make the action. So the haptic information consists of 2 different types. One is trackal information and kinetic informations. So there are different types, the types of haptic devices. The virtual reality is a one based devices is a one. Another one is in feedback based devices. So 2 devices I will be explaining here with respect to haptic. One is an haptic feedback. It generally improves the realism. The hand and wrist are the most importantly used uh, device for this. The 2 kinds of feedbacks are touch feedback and force feedback. When you touch the information on the texture or the temperature, etc., it doesn't resides over the contact. In the case of force feedback, the information on weight and inertia actually resist the contact on motion. 2 examples I will be giving, 2 devices. One, the first devices, it provides a 3D touch to a virtual object. So it has a 6 degree of freedom. So when you touch this object, based on the touching, when the user moves his finger, then he could really feel the shape and size of the virtual object that has been already programmed. So with the help of these devices, he can feel the shape and the size of the corresponding object. So another device is cybercraft. The device fits over the user entire hand like an exoskeleton and adds a resistive force feedback to each finger. It uses in 4 degree of freedom for each finger. So this is an example for this. Here also it uses an rendering concepts, how the rendering will be used, what is the basic principle of haptic interface. The interface occurs at an interaction tool that mechanically couples 2 controlled dynamic system. The haptic interface with the computer, human interface with the central nerve systems. These are all the 2 controllers which is going to take place. The characteristics are, it has low back drive, and it has a balanced range, and it uses some properties. Now we will be moving on to the visual representations. So before discussing about the visual representation, so we have discussed how the coordinates are there. In some places I have talked about the coordinates and all. So before talking about these coordinates, let me talk something related to the coordinates normally we will use in the case of a computer graphics, and then we will move on to the virtual reality coordinates. So first, there are different coordinates that exist. Before talking about those coordinates, let me give a simple example, and then I will explain with that example. That will be very clear to you. We have an object. Let us take, I'm going to draw a object, maybe a circle I'm going to draw. So while drawing this object circle, it has somewhere you are going to draw with a center of 0, 0 and with a radius of 5 centimeter or something. You have to have the values of those geometric structure. What geometry is going to construct the circle with respect to the center and with respect to the radius you are going to draw a object. This is called an modeling coordinate. What is the object you are going to model, which is called an modeling coordinates. So when you come to an system, this coordinates will be changing their name. The modeling coordinate systems are called as an object coordinate. Whatever object you have, that coordinate is called as a modeling coordinate system. Now this we have another coordinate called world coordinate system. In the case of world coordinate system, you can say, sometime you can say this as an modeling coordinate system also. How this world coordinate system is going to act? It's a base reference system for overall model, generally with respect to 3D, to which all other modeling coordinates relate to it. So generally the world coordinates are the coordinates for all other models. I have a circle, rectangle, all this will be put into one area, which is called as a modeling coordinate area. Then comes an viewport coordinate system. This viewport coordinate system, we can call it as a camera coordinate. How much portion can be captured by the camera? I have a screen, a very huge scene I can have, but your camera, the whole objects, whatever objects you have in that whole scene, whatever you are viewing, whatever you have in the whole scene, all those things are the world coordinate, and the objects in the world coordinates, they have called as a modeling coordinate or the object coordinate. Now we are viewing using a camera. What will happen? Whether can you able to capture the entire scene, whatever you are seeing through your eye? That is not possible. The camera can able to capture a few portions. The remaining portions will be discarded. So whatever portion the camera can able to capture is called a viewport coordinate system, or you can call this as a camera coordinate. And after making this viewport coordinates, now the camera has captured the scene, and that scene will be given to your device. So in the device, you will call the coordinate as a device coordinate. I think now these coordinates are clear to you. So I was talking about a modeling coordinate, world coordinate, viewing coordinate, and then device coordinate, 4 different coordinates with respect to the computer graphics concepts. Now we will be, based on this basic idea, we will be moving on to the visual perception in the reality, that is virtual reality. Now we can see you have a scene here. This is your real scene coordinate. Whatever you are seeing, this is a real scene coordinate. This is your virtual object that we are going to synthesize. So the coordinate with respect to real scene is called real scene coordinate. The coordinate with respect to virtual scene is called virtual scene coordinates. Now a camera is capturing a real scene. The coordinate with respect to this camera is called coordinates of the camera position. And then this virtual scene is given to an rendering to make a rendering effect. So the rendering, whatever value we have obtained is an coordinates of the camera position. So you are getting a virtual objects, and this camera, whatever real scene we have obtained, that is also given into the rendering to get the rendering effect. The alignment of real and virtual coordinate is called world coordinates, or with respect to the output you are making this. Now this rendering coordinate and the camera coordinates are given to the screen coordinates. So you have two screens here. One is with respect to the real scene. Another one is with respect to the virtual scene. So this two is going to be merged and you are going to finally produce one output. That output will be in the display devices. So the coordinate which is with respect to display is called display coordinates. So finally, this is the object the user can view. So this is the way by which the process is going to, the coordinates will be represented. I think I have showed already with respect to a tracker, I have showed a video. With the help of that, we can do that. Now, uh, just a recap of what we have discussed in today's session is augmented reality. What is an augmented reality, virtual reality, mixed reality, and an extended reality. So the augmented reality, it's overlay of computer generated content on the real world uh, that can superficially interact with the environment in real world. In virtual reality, it's totally an immerse effect. The user cannot see anything related to the real world. All the scenes are generated as a virtual reality. Mixed reality, it's a combination of augmented and the virtual reality. Last, extended reality refers to all real and virtual environment generated by computer technology and wearables, or the extended reality. It's a combination of all. So again, I will be showing a video with which shows an example for an VR. So with the help of a VR camera, so it is producing a object. This is in virtual Jurassic Park. So I have reduced the sound effect. Actually, when you wear the camera and you can see that, you can get the feel of the virtual reality. This is an example for a virtual reality. Another example. That shows the example for mixed reality. 1 minute. Yes. So it is a video which gives how the argument mixed reality is used here. In this video, we will see. So the people are wearing glasses. It's a special kind of glasses. So some of the clips have been captured in this environment. And later, He's wearing the glass and he's seeing how it is performed. Okay. So as I told you, all the images and videos presented here are taken from the internet source. So I will show you one more slide. It is taken from a lab, virtual reality lab. It is from, it's called JAXA, which is there in Japan. So the lab contains mixed reality objects. So they have created this object. This is the object which is going to be there. They have used a HoloLens for this purpose. So I went there. That time I have evident that how the mixed reality is working. So after wearing this glass, this is the point by which we have to stand. We can rotate or we can move the objects, so we can see the flights are coming nearby us in that environment. So this is the thing I wanted to show to you. I think I have delivered the content. So I can post some of the questions. I hope it was clear. I can ask few questions so that you can answer for those questions. Or if you have any queries, I can do that. So shall I ask some few questions?
Yes, ma'am. Yes, ma'am.
So that I...
Dear participants, now it's the open call for all. Any questions from your side, please post it in question and answer, or else you can raise the hand so that I will enable you to ask questions to the resource person. Can you please quickly ask?
Any questions? I think
It's open to you.
I think whatever we have discussed with respect, no, I'm just telling them whatever we have discussed with respect to the elements of AR, VR, and XR and MR and the applications. I have showed you with a clear video so that it will be clear to you. If you have any questions or any queries, you can ask me.
Ma'am, one question asked. I will, in question and answer session, they have posted the question. Do we need a separate devices for AR and VR?
Separate? I couldn't hear you, sir.
Separate devices. Ma'am, can you hear my voice clearly?
Yes, sir. But it's breaking in between. You need separate?
Sridevi, ma'am, can you hear?
Yes, sir. I can hear you, sir.
Do we need a separate? Yes, ma'am. Do we need a separate devices for AR and VR?
You are talking about what kind of devices, whether you are talking about an input devices or output devices. So I have already showed, when you are talking about an AR or VR, I have showed you in the first slide. it requires a devices. Without device, we cannot perform the any realities cannot be achieved without the devices. You required a separate devices for this purpose to be handled. You required either a device which can support with respect to your PCs, or with our respect to monitor, or a device which can support with your smartphones, or as some head mounted devices are required for this purposes.
Ma'am, next question is asked by Dr. Vasumati ma'am. Augmented and mixed reality difference is not clear.
Yeah, in the case of augmented reality, we have used, let us take, I have one screen. I can show you an example. You have this screen. Now, this real world is there. You are trying to append this uh, virtual object onto the real world scene. That is an augmented reality. So when it comes to an VR, what it does is there is no contact of your real world, no screen, nothing will be present there. The entire screen is generated by your computer. You don't have a contact with the real world. When you use this glass, I have showed you a Jurassic Park video. There you can see the entire screen is with respect to the Jurassic Park. All are generated sequences. When you go for an MR kind of thing, that is mixed reality, it has both your virtual reality, and some content will be appended into the virtual reality content to get a mixed reality. That makes an augmented reality when you add something. I have showed you a man. We have a person, last video probably. A person is there. His information is captured, and later that person is embedded into the particular virtual reality scene. Last video I have showed you that how that is done.
Ma'am, one more question.
Yes, sir, ma'am.
Yes, sir. You can ask. You can ask.
Good morning, ma'am. Ma'am, I am from Panipat Institute of Engineering and Technology from Panipat. My
Yes.
question to you is, I'm going to set up one AR VR lab in my institute.
Okay.
Already, I have purchased some of the equipment like HTC Vive Pro and Oculus Rift S. We have some machines also with the high specs. I would like to know from your experience, like we are not we do not have any experience in arranging any sort of lab. Neither I have visited any. So can you please tell me like how this AR VR lab can be designed? As I've seen, you have shown demonstration of one lab in your slide. So
Yes,
please
sir.
guide me.
That was the lab which is located in Japan. I visited that lab. From there, I have clipped the photos, and that I have shared with you. So what are all the I think you have purchased some of the devices which is required for making a virtual reality, and you said you have a high computing computers also. You have in your thing with the required softwares. You have it, so I can guide you whatever help you wanted. I can guide you, sir, by setting up your laboratory. You can contact
Okay.
me anytime.
Yeah. Thank you, ma'am. Thank you so much.
Thank you, sir.
Two more questions are posted in the QA feature.
Yes.
I will read the question. I recently watched Apple developers event happened the day before yesterday. They did AR emojis in visual combining with real-time footage. How do this AR technology become as marketing tool in future?
Sir, can you please repeat it?
Yes, ma'am.
I can understand that some Apple technology they have developed something. After that, I couldn't capture your
Yes,
point.
ma'am. Yes, ma'am. I recently watched the Apple developer event happened the day before yesterday. They did AR memo is in the visual combining with the real-time footages. How
Real
do
time?
this
So one
AR
second, real time?
technology,
1 second, sir. Real time?
real-time
Footage. Okay, sir. Okay.
footage, how do this AR technology become as marketing tool in future?
Okay. They in that what I have understood, I just read out from my understanding. Please correct me if I'm wrong. So he has watched some Apple event release. In that they have used video captured images they have used, and they are trying to augment that, right? And how it will be useful in marketing in future. That was the question. I'm right, sir?
Yes, ma'am. Yes, ma'am.
Yeah. So we have discussed in the case of AR, it's a real scene. You are getting it, and you are trying to embed it. So they have used the whatever what you have said. They have used a captured video, and there they are trying to embed something, and they are trying to give the reality view. So in the case of marketing, as I told you, suppose you are going to buy something. For example, you wanted to buy some item for your home. You wanted to check whether that is uh, feasible. I mean, whether that will suits for your home. You need to check it out. In that aspects, you can capture your place, or wherever you wanted to keep, that can be captured. And the whatever the product you are trying to buy, that can be used. For example, you are trying to buy some dresses, whether it suits you. You can check it out with this technology. You can take your photo, and you can click that, and you can check whether it suits you, and it will show you how it is looks like. So the future market will be mainly focusing on this kind. Now the people are moving on to the online marketing. So when you are buying something, if it is not suits you, then you have to send it back to this. But using this technology, you can just check whether it suits you, and then you can buy based on your mm, idea.
Okay. Ma'am, next question.
Yes, sir.
Can can I read, ma'am?
Yes, sir. Yes, sir.
Among these four types of reality, which one is the most preferably used in current technology scenario, and why?
All this are developing technologies. Still developments are going on. We cannot say this is the best and this is the topmost priority and all. Still research is going on. Research challenges are there in with respect to XR, MR, VR, and AR. But nowadays, in many applications such as gaming, um, and in educations, and some application medical field, they have started using this technology, but it was not full-fledged.
Any of the participants and participants have any doubt? You can
Hello,
raise
sir.
the hand. Yeah, yes, sir. Yes, sir. David,
Hello,
yes,
ma'am.
sir.
Yes, sir.
Hello, ma'am. Good morning, ma'am.
Good morning, sir.
Ma'am, actually, nowadays the people like common man used to experience this AR and VR. Actually, when we are going to malls, or if we are
Yes.
going to purchase any mobile, we are using this AR and VR technology as a marketing tool.
Yeah.
Yeah. So, what will be the future? Like in future, maybe it may develop further. Like so, even in movies like Jarvis, like Iron Man movies, they are using something called Jarvis, which is something real in time, actually.
Yes, sir. Hello.
Dave Chandra, sir.
In
Hello.
movies. Hello, ma'am. Can I able to hear me?
Yes, yes, sir.
Yes. Yes, sir.
Yeah. So, will it be in future? Will it be like an home-based thing, like augmented reality, or will it be like a device will come for a household thing?
Yes, sir. That's why I have told you it's still the research is going on for developing those technologies. It's not full fledged. It's a technology which is still requires uh, more challenges are there to make it. So you can take it as a research problem and you can try to solve that.
Okay, ma'am. Thank you, ma'am.
Thank you, sir.
Any of the faculty friends, you want any questions, you can ask. So, person is here. Ma'am, one more question is posted in question and answer.
Yes, sir.
What disciplines are involved in AR, VR, MR, and XR? And what is the role and scope of the software engineer?
Uh, they are talking about discipline. What
Yes,
exactly?
ma'am.
Which
What disciplines are involved?
what which I mean the who can develop all these
Yes,
things?
yes, yes, ma'am. Yes.
Yeah, if you are aware of, because everything when you are talking about tracking everything, it uses an computer vision and an image processing techniques. So if you are in the field working in the field of computer vision and image processing, and then you can able to make out good systems, because everything deals with respect to images, so you should have a knowledge on image and computer vision techniques.
And then it will be common for all specializations, ma'am.
No, I'm not talking about common for all specialization. So his question is related to software engineer as a developer. Who can do this? If it is if you are more towards inclined towards image processing and computer vision techniques, then you can take this as your problem and you can solve it. I'm not talking about computer science or electrical students or triple E students. It's generally if you are towards these areas, then you can produce a good result.
Any more questions from the
And
participants?
also one more thing, computer graphics. If you have a good knowledge on computer graphics, then you can able to generate a proper visual representation.
Any of the participants have any queries? You can raise the hand or else you can post the question. It's almost the time to end of the session. Okay, participants, I think there is no more questions from your end. Dear ma'am, thank you very much for your valuable and informative content on elements in AR, VR, MR, XR, and you have detailedly explained about the three concepts on haptics, tracking, and visual perception. It is very much useful for all of the participants, and it is related to their research, and you have explained more on the research problem and real-time appliances. Thank you once again, ma'am, for your valuable time.
Thank you, sir. Thank you very much.
Thank you, ma'am.
Thank you
Thank
for
you.
inviting me and giving me opportunity to make interact with the few more faculties. Thank you, sir. Thanks
Thank
to
you,
all
ma'am.
the participants who are there here. Thank you very
Yes.
much.
Thank you, ma'am. Thank you.
Thank you.
Dear participants, the morning first session is over, and the feedback session has been posted in the chat box and also in the WhatsApp group. You have the link and you can fill the details of the feedback. and please complete it. So we have time for half an hour to join. So if you want any break, you can take half an hour time, and please quickly join before 10 minutes. Vasumati ma'am.
Yes, sir.
Vasumati ma'am, you have asked one question.
Yeah.
Yeah, computer graphics versus computer vision.
Yes, sir.
Yes, ma'am. Actually, our resource also went.
That's okay,
So
sir.
as per my knowledge, I will tell, since I am in this field, I will give the explanation. So the
Okay,
computer
sir.
graphics is entirely that is graphical content, full of graphical content in terms of 1D, 2D, and 3D. So nowadays we
Mm.
are moving with 7D, 5D, and all. So
Mm.
based on the some animation tools and some other software, we can make the image in different formation. We can form in different notation. But computer vision is the group of algorithms which we are developing. That is,
Mm.
nowadays we are the trendy words like artificial intelligence, machine learning, pattern recognition, etc., etc. So these are comes under the computer vision. So usually in abroad universities, the course like computer vision engineering they will have. So mostly they have the content like this. So in my, as per my knowledge, the computer vision is nothing but the full and full of data science concept will come for visualizing the real time content.
Okay, sir. Thank you, sir.
Thank you, ma'am. Thank you. Dear participants and faculty friends, I hope mostly everyone is here. And if you want any break, you can take break and you can come back, and please join on time. And as per the AICTE norms, please follow the regulations as per their instruction. How to maintain 80% of the attendance, and you have to, at the end of the session, you have the test which should maintain of 60 percentage mark. And also based on this eligibility criteria, the digital certificate will be received by issued by the ATAL Academy. So please maintain it. I hope everyone know. And if any discrepancies during the sessions due to the internet connectivity and some issues, please let me know so that I will connect with my computer operator team to solve the problem.
Sir, good morning, sir.
Ma'am, Sudha ma'am, please tell ma'am.
Sir, do we have the test on Friday afternoon, sir?
Yes ma'am, yes ma'am. Friday afternoon.
Thank you, sir.
Yes. Dear faculty friends, some of them asked the contacts of the resource persons. Definitely, I will share the contacts of the resource person at the end. And also, I have shared the content yesterday in the Google Drive. In the registered email ID, which you have given in AICTE portal. If you not received, please let me know so that I will give option for accessing the G Drive. In that maximum, all the content from first to last day I have given. So only the company experts who given in the first and second day, that is Eon Reality. So they only given the video content, that is live content alone. So that YouTube channel link also I will share it in the G Drive. That also you can access for your reference. So the remaining academicians has been shared the content for your reference. I will share it in the G Drive. So you can make it use of it for your preparation and for future reference. Surendran sir, good morning. Surendran sir, can you hear my voice?
Yes, sir. Sir, can you hear
Sir?
me?
Yes, sir. Yes, sir.
Okay,
Good morning,
fantastic.
sir.
Morning, sir. Morning.
Morning, sir. So, how are you, sir?
Sir, doing great, sir.
Fine, sir. Very good. Very good.
How is it going, sir? I've been in the sessions back and forth.
Ye-
You know.
yes, sir.
So you're starting at
We-
11:30.
Yes, sir. We will start sharply at 11:30. So
Okay, sir.
some of the participants went for some break. So we
Okay,
have
sir.
completed at 11 a.m. sir on first session.
Okay, sir.
So our session will be sharply. We will start at 11:30.
Okay, sir. No problem.
Sir, do you want to check anything?
Just
You
quickly,
going to- Yes, sir.
I'll share my screen, sir. I'll see whether it is fine or not.
Yes.
Okay. Share screen. Okay, my share screen is disabled.
Oh, share screen is disabled, sir. Now you check, sir.
Yeah, now it works. Share sound. Okay, I'll click share. Can you see my screen, sir?
It's loading, sir.
Okay.
Yes, sir. Yes, sir.
Okay, super. So now it changes, right? I mean,
Sir, do you going to show any videos
yes, sir.
or
I'm going to check
any
the
live demo?
live demos also, sir. Then I have a few videos also.
Okay.
Can we check quickly the sound check?
Yes. For that only I am asking, sir.
Okay, sir. I'll just. Can you hear the sound?
Давай.
Yes.
Okay, audio is correct, right?
Yes. Audio is okay. Fine, sir.
Okay, sir. Fantastic, sir. I think that's it, sir. I'm settled.
Okay, fine. Good, sir.
Super cool. Okay. Sir, if just to make sure, my internet connection is, kind of, because since yesterday, if I disconnect somehow, can I reconnect, right?
Yes, sir. Definitely. You can record.
Okay, sir. Till yesterday, it was okay, sir. It was very unfortunate. There was a accident right in front of the home.
Oh,
So one tractor actually right into the, the cables wherever it comes. So
okay.
they did not actually remove. So I'm using my mobile phone's internet.
Okay.
Definitely this will run out. So I have one more mobile here.
Okay.
So just in case, I'm telling you.
No issue, sir. No issue.
Super, sir. Okay, 11:20. Okay, sir, 5 minutes. I'll be back.
Yes, sir. You can.
I'll be in the meeting. I'll just refresh and I'll come.
Yes, sir.
Thank you, sir. Okay, Martin sir, I'm back. Just want to let you know.
Yes, Surendran sir, I think he's in a call.
Oh, thank you,
All
Alex
right,
sir.
yeah.
No problem, sir.
Okay. Martin sir, yeah. Okay.
Okay. Surendran sir, are you here?
Sir, I'm here, sir.
Yes, sir. Good morning, sir. Good morning.
Good morning, sir.
Good morning and welcome you, sir. I am handovering session to Alex Matthew.
Okay, sir.
Yes. So good morning, the faculty members, panel members, and our guest for the day. Again, we are back with another expert who is having a great experience in animation and visualization. Sir, I welcome you all. Before that, I would like to give an introduction about Surendran K. Sir. Surendran K. is working as a senior assistant professor at VIT Vellore with the Department of Multimedia. He did his B Computer Science at Anna University and his MS in Computer Animation and Visualization from Liverpool John Moores University, UK. He has got 7 years of industrial experience working with international animation studios such as DreamWorks and Nickelodeon. He contributed directly as a lighting artist to popular projects such as Superman Returns, Monsters vs. Aliens, Life of Pi, Madagascar, and Boneyard, the movie, to name a few. He has 12 years of international teaching experience and delivered semester classes in London, Singapore, and China. Surendran is a certified professional in Autodesk, Adobe Photoshop, and certified programmer in Unity game engine. Surendran sir is also a movie fanatic, cyclist, and an avid gamer. Sir, I welcome you to the session, and hopefully we will really get benefited with your upcoming session. Thanks a lot, sir. Thanks a lot. Thank you.
Thank you. Thank you so much, Alex Matthew, sir, for an amazing introduction. And so, shall I start, sir, then?
Yes, sir. Yes, sir. Sure. You can.
Okay. All right. Before I actually start, a warm greetings from me to all the faculty professionals online, to my colleagues, and especially I would like to say a few words of thanks to the management of Karunya University for making this dream come true. Of course, with using the tools, the coordinator of this very event, Martin sir, Dr. Martin Sagayam sir, for arranging everything, and Alex Matthew sir for being here. I've been seeing him as well, coordinating, and also I have a few more people who I actually need to thank you about, like Abraham Chandy sir, then Amir sir, Melin Gilbert sir. It's an overall effort, and I'm extremely thankful for all of your single person's effect to put together this amazing event. So I will have this opportunity to talk to the fellow faculty members as well. Okay, a very good afternoon and a good morning-ish mixed wishes to all of you. I think I don't have to say any more about myself. I think Alex Matthews have made it really clear. So without further ado, let me straight away go to my presentation. Let me quickly share my screen. Okay, sharing. Okay, so I believe my screen is being shared right now.
Yes, sir. Perfect.
Okay, super. Let me go full screen. Super cool. Okay, so what I'm actually going to talk about is I have been attending sessions also, and I think most of you guys here in the participants would be attending sessions. This is a third day. So even the previous session was talking about one of the online tools, Xeon, basically, the application. So what I'm going to approach in my session is basically I'm going to take a few things about virtual reality and augmented reality in a commercial field. I'm not going to go very into the nuances of okay, getting the VR and AR functioning, or how a VR and AR functions. Okay, what are the basic interactions available? So I'm not going to touch all of that, because I have changed a little bit in my PowerPoint presentation according to the sessions that has been done already. So I believe this will be straightforward. And also, given my profile, I cannot be too formal, so I design games. Okay. So of course I teach designing games. So my session would be like a little bit lighter. Okay. So let's have a lot of fun. And I would really like this session to be more interactive. We will be having the interaction session at the end, I believe. So all the participants, if you have any doubts generally about VR and AR, and or towards what I have presented in my presentation, please do go ahead and ask the questions at the end. I would really appreciate it, and I would really try to answer you in the simplest way possible. Okay, the title, the formal one that says the role of AR and VR in real-time applications with CoSpaces demo. CoSpaces is the tool that I'm going to touch at the end of this session. Until that time, my presentation would be about the generalized information on AR and VR and how it is being commercialized as we know it. Okay, and again, I would like to appreciate AICTE's sponsorship towards conducting all these kind of sessions is absolutely amazing, and combination with Karami and ATAL. So I'm here really thankful. And just a little bit about myself, as I already said. So as a profession, I'm a professor. Apart from it, I'm a game developer. VR and AR dev is one of my hobby, and I do a lot of YouTube videos and blogging as well. And I'm certified in Unity, Photoshop, and Autodesk. But basically, these are needed in order to, get into a conglomeration of what I'm doing. These are some of the projects, as Alex Matthew said, introduced me. So if you don't understand what I actually said in the previous in this slide, so I believe a few of this will make sense. These are some of the projects I was working when I was in the industry. So I had my direct contribution to these projects as a lighting artist. By the way, what my job was, let there be light. So that's what I was doing. Lighting comes at the very end of a pipeline. So we used to work with a lot of extreme pressures when it comes to industry. You could see my hair, that's the result of, I'm not just saying that it's going to be hectic, all other jobs as well, but this is going to be like more compressed at the end. The people from my field would understand how difficult a lighting artist job would be. Okay, I was actually a part of a lighting game designer as well in, I think, Sony PlayStation. Some of you guys might know this, God of War. Okay, so if you're a gamer, you would definitely come across that. So these are some of my projects I was a part of. Okay, so coming to today's topic. All right, back then, okay, our moms especially used to say, please don't sit, close to TV while we are watching. It will spoil your eyes. Please stay away. Please be at the distance. A lot of advices, friendly advices, like a caring advices, and what you would do, like cartoons, all those kind of things. We used to get yelled for what we are doing here back then. But now, things is completely, we are attaching a television, more like not just one display, but two displays right to our eyes. This is what the current situation. Okay, so what changed? A lot of things have changed. So first thing, when compared with this to this, okay, straight away, what would you think? So that one question that arises to us. So VR and AR is a disruptive technology. That's our question. Because, it's not looking healthy, and it, of course, it doesn't sound healthy. So why VR and AR? It must be disruptive. If that is the question that arises, well, we don't have the answer. When I say we, the people who are working with AR development, or the current industry that is working with augmented reality or virtual reality, we don't actually have an answer for this right away. Is it disruptive? Well, basically, sooner or later, one thing that we know is we will be needed or forced to lean towards VR and AR. On what basis are we saying this? Well, what happened to smartphones? Very simple question. Okay, what happened to smartphones now? Okay, so how many of us actually does not have a smartphone is another question. Okay, so before it was advertised as a luxury, where many of us never wanted a mobile phone. Then it became a need. Then it became essential one, like must-have kind of thing. Then we almost ended up in having a mobile phone for all of us. In fact, the recent survey says the number of SIM cards are more than the number of total population in the world. So dual SIMs, what else? Okay, so we are not even having one number now. So we are actually having two numbers for two different purposes, 3 SIM cards, 4 SIM cards, depending upon the nature of the job that you are doing. So what is happening now is SIM cards are more in number than the actual human beings. Well, let's know that VR AR is an inevitable technology. I did not say these words. Okay, these are what the literature says so far. Okay, why it becomes inevitable? Well, let's go quickly back to the technology when it came to this world for the first time. Okay, what happened to computers? Internet. What happened to mobile phones? Okay, which I just said. What happened to online shopping, especially in this pandemic situation? Okay, chat applications, 4G tech, 5G tech. Okay, even memes. Okay, memes was actually considered to be, even I have gone through a lot of studies about memes. Memes are the one which convey most happening matter faster than news. Literature denotes that. Okay, and it's fun. At the same time, it actually has a lot of meaning that it can able to convey without saying a single sentence. Okay, the reaction of popular reactions or whatever. So meme is one of a very good example of how we have accepted these things into our life right now. As you are aware, you know what is happening with 5G. Okay, I accept, okay, technology has problems as well. Even the movies has been taken how 4G signal disrupts the life of birds. Okay, even 5G going to be slash more heavier than what 4G have been doing. So we are aware of that. I am aware of that. The general public is aware of that. Government is aware of that. But still, why they are actually bringing into this? Well, basically, let's not go into economics and politics. What I'm trying to say is a technology can be used in both ways. Okay, and then only then it becomes valid. For example, you would not accept you a 1 rupee coin if I give you if it does not have the backside of it, or money in Indian rupees is, or whatever, your money is not valid when it is printed only on one side. So black and white, front and back, you know, in this world, everything comes in two. Okay, so there is a balance. Well, basically, it's up to us how we are going to use a technology. We can use it disruptive, or we can actually take into a good stand about that. Forget about VR. Before I go to the next slide, let me tell you one thing. I think you guys are aware of a emerging technology called 3D printing. 3D printing can be used. It's a gift to the humanity, if you ask me. It's a gift. Okay, that 3D printing have been used amazingly at one part of the world, where the other side of it, the technology has been used to cause disasters. For example, if you go and Google it, you can yourself say, there was a group of people led by, I don't remember the doctor's name. He is printing working liver, human organ, using human organ tissues extracted from other human. Instead of using any other material like plastic or metal, he's using human tissue, okay, extracted from well-working organ of others, using the tissue to print a kidney, a liver that actually works. Okay, imagine, guys, if you have a liver problem, if this becomes mainstream, all you have to do is Control P to get a new liver, print. Okay, so they are printing organs. That's, you know, something, it's more like an action of God. Okay, on the other side of this technology, people, a group of other people who have found a way to 3D print working AK-47 and rifles, including plastic bullets that will cause fatal damage when shot. And worst case scenario, they have given the template of printing that rifle online, which means if I have a 3D printer available with me, all I have to do is download the template, Control P, I have myself a working rifle, including bullets. All I have to do is wait for 6 hours for the printer to finish printing it. I'm not even joking, you can Google it. So see, how things can be used depends upon how we approach the technology. And VR and AR is exactly like 3D printing. Whether we gonna use or we gonna harvest the betterness from it, then it's going to be amazing. Or we will have a problem. Okay, so okay. All right, so I think we'll go for the next one. So that's the point I'm trying to put across. Enough said about it. Let's see this. If any of the reason what I said before did not convince you why VR and AR is going to be the future, let's talk statistics. Well, this is actually from 2016 to 2027 assumption market in USD $1 million. Okay, if you take a look at it, so in 2016, it's not even started. Okay, and especially what you need to be sure of is take a look at this HMD, head mounted display. I think by now the participants would know what HMD stands for, I believe, or else I will actually explain it when the right time comes in this presentation. So HMD is this purple color in the graph. Unimaginably, it's increasing. By the way, this is not Corona graph, okay, because these days, these graphs are almost the same. All right, so it's rapidly increasing. By the time of 2027, okay, almost all of us, everyone, okay, mark my words, who are a participant in this particular presentation, at least 85% of the whole crowd, I'm talking about only us, might have either come across or have used a HMD or might own a head-mounted display for yourself. Okay, this will happen, or they will make it happen. Either you can be a consumer or you can be a developer, but at one point of time, we have to come across it. Okay, so we are in 2021 right now, and in another 5 years, okay, so this is going to be extreme. All right, so this is the market growth, and that's exactly why many manufacturers and social media is targeting towards it. Well, let's take a look at this person. Okay, our very own Mark, we know him. Okay, he is the CEO of Facebook. Okay, and he recently bought a company called Oculus Rift. I think you have heard about this Oculus Rift. Oculus Rift was one of a major manufacturer of virtual reality head-mounted display equipments. Okay, and they were so good that they were leading the market. A couple years before, Facebook completely bought the company, including the manufacturing area of Oculus. Now Oculus is owned by Facebook. And why do you think that has happened? Well, these market leaders or social media giants, they know what is going to be future. Okay, so well, actually he got that right, didn't he? He completely bought it. Now they are offering Facebook in virtual reality as well. Why? Because my perception as a individual, okay, this is not coming from the input. As far as my knowledge goes and as far as my experience goes in virtual reality, what I'm looking at is I'm looking at a virtual society in the future. I wouldn't be amazed if that happens. Okay, all those things. I think you guys might have seen a movie called Ready Player One. Ready Player One is actually might happen. I don't know what would happen when that becomes reality, because as I said before, there might be advantages, there might be disadvantages. The first disadvantage would be like greeting people in physical, bone and flesh. Well, you know what the pandemic has showed us already. Like, for example, I would pretty much stand in front of you to give you this presentation. Okay, looking at the face of all of you guys. Now what happens? See, we are taking classes like this, we are communicating like it. So the pandemic showed almost a glimpse of the future. That's how I see it. Okay, this is my own perspective. Okay, and if the future, this is a new normal. Already people have accepted it. Most of the IT companies sent most of their employees and told them permanently, hey, you know what, please work in home. You don't have to come back to office. Even pandemic is over. You know why? Because company have seen enough that how much money they can able to reduce. Air conditions are not running, cab services are not running. You don't have to give allowances of bus and trains anymore. There is no train passes from the government. Everything has been slashed away. Okay, only the company servers needs to be running, so people would be joining there from their homes. They are giving you, demolishing all the extra expenses. They will give you 1,500 as a internet allowance, done and done. For companies, IT companies, I mean. Okay, I'm not inferencing this from anywhere. I have seen it. So what happens is people have actually seen how much potential this new normal has, and they are trying to make it normal even after the pandemic. Okay, and even a normal companies, even we are thinking like that. You know how ahead social media giant need to think about, and that's what Mark did, and that's why Facebook procured Oculus Rift. So, what's next? So, well, the thing we have actually seen. So, virtual reality, augmented reality, mixed reality, hyper reality. Okay, people are giving you, and we have been bombarded with all these kind of technological words. Okay, hang on a second. At one point of time, where are we? That is the question we need to ask ourselves. The real question is where we will be. And that makes a big difference between what we are looking at now and what we would be experiencing in the future. All right. So what is VR and AR? Okay, that the previous question is what I'm trying to address in this whole presentation. Okay, what is VR and AR? As I said before, I do not have a very explanatory slide to talk about VR and AR, because by this time you guys already know what is virtual reality. Okay, so formalities. So I have a very small slide that says what is VR technology is. VR technology most commonly uses virtual reality headsets. I really wish I could show you one, but I never see this coming because I'm in my hometown. I did not bring any of my kit along with me, and lockdown is in place, so there is no way I could travel now. Well, anyway, the headsets are nothing but HMDs, head-mounted displays. In the first slide, we have seen one guy was wearing it. That's HMD, and that is a part of virtual reality because it deals with immersiveness. Okay, what is immersiveness? That's going to be my second slide. I really don't want to read this to you guys, and I believe you already know about virtual reality. It's a combination of realistic images, realistic sound. When I say realistic sound, I mean surround sound. Okay, and that's how there are certain things to make you believe, okay, that is real, because your brain, it uses sixth sense. Okay, it knows which is real, which is not. So virtual reality is a tool that would fool your brain to make it believe that something exists, but in reality it does not exist. That's why the name suggests virtual reality. There is a reality, but it is virtual. Okay, that's what you need to make sure your brain understands. The more believability a virtual reality device gives you, that's the victory of that VR simulation. If you are not into it, or if you still forget to believe that you are in a different world, then the simulation is not good enough. That's how we scale it. Okay, how much immersive a person is, That's the scale of virtual reality simulation quality. Well, hang on. You keep on saying immersive. How would you explain immersive? Okay, what immersive? How immersive? Let's take a look at this video. Okay, and I think you will understand what I mean. This person, okay, he's in a mall. Okay, he's first time experiencing virtual reality. I think some of you guys came across this video already.
Давай.
So he's
Алёша,
very happy.
дорога.
He started everything, a lot of fun. He's, you know what, he is waving at. Guys, one thing you need to understand, this person is wearing surround headphones and is experiencing a virtual reality using HMD. Okay, and what he is seeing is what we are seeing. So this TV is for viewers, which is like, you know, people like us. Okay, so this is a broadcast in a TV of the same thing what that guy is experiencing in his HMD. In HMD, take it from me, it's so realistic than what you see in the TV because it has Fresnel lenses. I think it might have, by this time somebody have mentioned this. Fresnel lens is what, it's more like a soda glass that actually zooms the pixels right into your eyes. So it looks very, you know, realistic. Guys, this is a simple most explanation I could give. I really don't want to get into the because Fresnel is a word from science. Okay, so but if you are interested to know more, you could be able to, you know, search on the topic. Coming back to this guy. It's a roller coaster, so he's actually taking a look at it. Let's go ahead. Can you see by this time he's already losing his balance? Okay, because if you take a look at the TV, you know, it's the altitude of him right now is so high according to the you know, immersive experience he's having. Okay, now you see this is the most exciting part of all roller coasters, right? Right at the tip of a dip, where the next second you will actually almost free fall, and that's exciting factor of roller coaster. See how this guy reacts. Okay, basically it's extremely funny for us, but not to him. Okay, that's not just having fun, it's frightened. Okay, so people react in a different way to virtual reality. Okay, let me go back to the first slide I was talking about. So is it disruptive? Well, it depends. Okay, certain things, it's like, for example, you know, you are so sensitive towards the heat. Like, for example, you are handling a hot vessel, okay, which has some beverages. Some of us are so sensitive towards heat. Some of us are not so sensitive towards heat. Same like some people will take the immersiveness to the next level. Okay, they are so frightened, and some of them still train our brain saying, you know what, okay, this is not correct, this is not correct. Okay, I'll tell you a secret. Okay, this is my secret. If you happen to have a frightening situation in virtual reality, close your eyes. You will thank me later. Okay, because the people outside of what, you know, the viewer will not know whether your eyes is closed or not. But if you're so frightened, close your eyes. So it seems like, and you can able to stand very still. People would be thinking, wow, this guy have guts. How he manages. Okay, well, actually you are closing your eyes inside. Okay, this is my very own secret. You would thank me later because I have done it several times. There is no shame in saying, because, you know, my definition of entertainment is different. I really don't have to be horrifically scared. I'm talking about some very scary VR simulations. Okay, If you take a look, okay, this guy laughs very hard. Okay, hang on a second. If you take a look at it, it takes that many people, okay, to calm him down and see his reaction. That's not fun. Okay, he's frightened. All right. Well, why did I show you this video is because his reaction is what the victory of VR simulation. I'm not being, cruel. What I'm trying to say is the simulation is so, real that the sound, okay, the immersiveness, the definition of word immersiveness is given to you by the combination of realistic surround sound, okay, realistic visuals, okay, in combination with two, then only then your brain will be fooled. Okay, and that's the simulation effect of virtual reality. If that person is not immersive enough, he would have never react this way. That's my point I'm trying to put across. Okay, now let me go back to my slide. So I think you guys know what's immersive. Okay, well, so where do these technology come in? Applications. Okay, whatever I showed you now is, okay, one guy getting frightened with VR. Okay, what's up with that? Well, that's not it. Before we get into the applications, we need to see what's a real difference between an augmented reality and a virtual reality. The key differences are, first of all, take a look at the red ones. In augmented reality, the user maintains a sense of presence in the real world. If you go back to the video that we saw in the mall, that person have been completely disconnected from where he was, which is a mall. He's standing on the very floor of a mall, but his brain has completely forgot that. And that's exactly why he was losing his balance. He was trying to fall. Okay, all these things happened because your brain has been disconnected from your physical location where you literally were. But in that's in virtual reality. In augmented reality, the immersiveness is not there. Okay, why? Because it's a superimposition of 3D things, elements into your camera feed. This is a basic definition of augmented reality based on your mobile phone cameras. But virtual reality needs ultra realistic and extra powerful devices such as Alienware laptops and PCs and high powered graphics cards and processors in order to render those kind of simulations. And that's why virtual reality is so immersive and augmented reality is not. But when you ask me a question, which is more commercialized, which would be more commercialized? If that is your question, I would any day say augmented reality is going to be commercialized first. Why? We have the tool already. All it takes to implement an augmented reality in 2021 is your mobile phone. Okay, can you believe the mobile phone I'm holding right now is more powerful than my desktop computer in 2002? That's the fact. Okay, my mobile phone is more powerful than the desktop which I had. So, you know what? It's complementing each other. Augmented reality needs a kind of media core processor at least to be dealt with, and your smartphones these days are equivalently powerful even to simulate virtual reality. So it's easy for the companies to implement and bring augmented reality to us. If you don't believe this statement, have you ever heard about a game that was so popular called Pokemon Go? If you come across that name, then you know that augmented reality is already around us. Okay, and that's the power of it, and that's fast. It's actually grasping its market value. Okay, so augmented reality needs a mechanism to combine virtual and real worlds, which is given by your smartphone, and it's hard to register real and virtual. Okay, but in virtual reality, sensors are under the control of system. That video was very pretty much straight example to what I'm trying to say. His senses was controlled by a fake simulation. Need a mechanism to feed virtual world to the user. That's what the systems come in. And hard to make VR world interesting. As I told you before, even a little bit immersiveness is missing, which means the quality of the simulation, quality of the audio is not up to the mark. Your brain cannot be fooled. Okay, so one first application, virtual tools. This already showed, the pandemic showed the power of it already. I'm going to make you understand with a very simple example. I'm going to take our VIT Vellore campus. Okay, I'm going to give you a task. For example, reach Chancellor's office in the main building. Imagine you are actually a PhD scholar, or you're actually a prospective student or a parent who's going to visit your student or the Chancellor's office in VIT for the first time. So what I'm trying to help you is I'm going to give, hang on a second, I think I have a Q&A. If possible, tell some more in AR with examples and understand the VR clearly. Yes, Shankaran sir, sure. Well, once I finish with it, then I'll concentrate on the things that you need. Definitely. Thanks for the question. Anything else I have? Okay, it's just good morning. Okay, so virtual tools, pandemic showed the power of it. Okay, if you take a look at this, this is basically a type of augmented reality. Okay, this is a map I'm giving you with the task reach Chancellor's office in the main building. Okay, you take this, how would you find, okay, you actually would start from somewhere here. Okay, this is Katpadi Road, you are new to Vellore. It says main building here. This is not a representation of main building. I don't know what is this. Okay, then how can I go? So the thing is, this is one. What if I'll give you, okay, confusing, how about this? Okay, got it? Well, okay, so what about if you actually take a look at it now, this is more clear than before. You say, hey, wow, okay, main gate, this is a main road, fine, I can go here. Okay, this is a T-cross, so you can able to go left or right. Straight ahead is the building. Super cool. Thank you very much for this map. Okay, I will go. But what if I ask you some more questions like, okay, the ones that you see, Chancellor's room number, which floor, left or right, what color? So these kind of things, if I ask you, or if you need in order to navigate, then what you would do? So again, this is not enough at one point of time. Well, all you need is this. Take a look at it. It's loading. This is our very own 360-degree campus. Okay, and Shankaran sir, by the way, this is a very good example of augmented reality. Okay, because you have a real scene and we have augmented it on top of something else. This is literally the road. There is no differences. The tree is a real photograph. We call it 360-degree photograph. Okay, this is a main gate, and your task is to go for Chancellor's office. Okay, you never visited before. Click on main entrance. That takes you to the main entrance. So now you are the main entrance. You can take a look at it. Okay, and 360-degree you can able to look. All right. So now you are free to go anywhere to go. You go to the plaza, which is your right in front of the, right in the middle of plaza. Okay, where our health center is this way, MGR block, you already know from the map. So you go to the MGR block.
MGR block, also
Okay.
known as the main building, is named after former Chief Minister of
Okay, so now they have made a video of a student as well who talks about every single place you can able to look at, even before you ever visit our campus, you can able to tell how many lights on the roof. You could pretty much say that. Okay, and you go to the Chancellor's office,
we are a 33-year-old institution.
Our Chancellor's message is also in
as a small college with 180 students. Now,
so pass it for now. And this is Chancellor's office, and you know what is the color, which room, left or right, what is that, and what is the texture of the building. You could able to tell everything. Not only this, the whole campus is given you with the pin mark like this. You can pretty much go, for example, sports complex. That takes you straight to the sport complex. Okay, you can navigate your swimming pool entrance if you want. Every single brick or every single building that has been built inside the campus is given you in an augmented reality 360 experiences where you can able to go back and forth. Not only this, if you have a virtual reality device, Okay, you can able to go complete VR with it. Okay, when I say virtual reality device, this does not require Oculus Rift kind of mainstream devices. What it needs is just a Google Cardboard. I'm going to talk about that very soon now. Okay, so this gives you all information you want. I think I answered that. I'm new to this webinar anyway. So I'll just, I hope you guys understood what I'm saying. Now, if you go back to the screen, okay, my PowerPoint presentation, when you compare with the details that is given to you in this map, compared with this map, compared with your actual representation of the campus, which one would be less confusing? And that, you know, without explanation, you know which one is more sophisticated. Now, what happens is this virtual tour are one of the extreme amazing application of virtual reality and augmented reality. Okay, forget about this. Actually, we can know our way around. If you're going for, like, for example, I studied my master's in Liverpool, John Moores University. You guys wouldn't understand if I explained like 7 or 8 years before. I never been to UK. I don't know which cab to catch. I don't know which road I have to go. So much difficulties. I only wish if I had this kind of virtual tool. They have it now, but at the time there is no AR and VR. Okay. Now, impossible possibilities are here. Studying an engine. Same similar example. Imagine you are a mechanical faculty, or I'll take, you know, any automobile or whatever. This is what you guys see in books, correct? So what we will see in books, this is a main part of the engine. This is a pulley. This is what it does. This does. Okay, 16 to 1 mm, 12 nanometer, blah, blah, blah. Okay, clutch cover, how it moves, you don't know. Okay, dowel pins, how it is fitted, we don't know. Okay, the best possible, Martin sir or Alex sir, if nobody's gonna talk now, can I put this in my neck? Yes, the headphones. Yes. Oh, okay, thank you. Yes. Wow. Okay, all right. So this is what we would do maximum. Okay, we would guess our students to imagine what is going to happen. What about this? A more sophisticated image, like VAT example. If your student's having problem, we're gonna give this. Okay, take a look at it, because this one shows where is the gas chamber and where is the cylinder and where would be the heat dissipation would be done. All these kind of things we can able to tell them, and this is more sophisticated, a 3D representation when compared with the first one. This is more okay. If we go to the next one, this is even sophisticated. Okay, you could pretty much say, you know, how much animation it is. You could actually see everything in person. All right, how the pulley is moving, the movement of everything, the rotation, whether it is clockwise, whether it is okay, anti-clockwise, you could able to understand all of it. Okay, even now, this is what available for the students. Let me quickly show you that. The students now,
so this is our engine fully assembled, and we can
assemble and
rotate the cranks to see.
They can literally assemble and disassemble a 3D engine by their own hands with a manual that comes with it. Let's take a look at it.
Welcome to Wrench. As you can see, I've got my table lined up with all my engine parts on and the engine block right at the end there. And I am so excited to put this engine together. I cannot tell you how much I'm looking forward to doing this. Now, I was a huge Lego builder in the past, and as a kid, I just used to love building things. So building an engine in virtual reality and actually learning how an engine works at the same time sounds super interesting to me.
Okay, so we don't have to play this whole video. Let me skim through. Can you see the wrench size? He can reduce himself, and he can able to, you know, assemble and disassemble every part, you know, one by one. Okay, so well, basically, if imagine one student finishes assembling or disassembling one whole engine, what literature shows is the retention rate of the students have gone sky high when compared with books. For example, I think you understand what I'm trying to say. If I'm going to study this engine, my memory power is limited, and besides, the more you show, the more you show, it's easy for us to remember. Okay, but imagine constructivism is one of the very teaching learning technology. I mean, not technology, teaching learning theory. Constructivism, connectivism. Constructivism in one theory, okay, which actually says when a person does something by hands-on experience, then the retention rate, the memory of that person goes really, really comparatively high when compared with reading or other things. Okay, so what virtual reality is giving the students to an opportunity is they can able to practice it by themselves. Okay, they can literally take this page of engine and puts by it part by part. Okay, and that's one of a very amazing application which I have literally seen. Okay, what about commercial application? I'm talking about education and other things. What about commercialness? Take it from me, I'm a hardcore gamer. How it actually puts a gamer into the scene, it's really amazing. Let's quickly take a look at this futuristic gaming console. Okay, so I think you got it, what I actually trying to convey here. The gamers, one, okay, even me, all right. The one complaint we have when we play games is, okay, this system is not built for me. Okay, put me up there, I'll show them who am I, what I can do. But it's more like a rage talk, all right, when you are actually, especially when you've been shot down, when you are not trying to shoot somebody, okay, when you are unable to achieve your target in the game, the game rage gets into it. We usually say these words, put me there, I will show them who I am. Okay, well, ta-da, they have put you inside. Well, the thing is, there is no more button pressing, because shooting is never been clicking. Okay, that's what people used to say. Okay, this is not shooting. So what happens is, this is a 360-degree treadmill which allows you to run according to your need. For example, pressing the shift button down will not make your character run faster anymore. If you really want to run, you have to run. Imagine, okay, if you think, okay, what's an advantage of this? Let me tell you this. Imagine the open world games like GTA, Grand Theft Auto. Let's not talk about it. Okay, this the blood and gore and other things, but it's an open world game. Imagine that you have to run yourself physically in a 360-degree treadmill like this. You know what happens is, without you knowing, you are giving a lot of exercise to your body. Okay, your calf muscles, your bone, everything is getting dense here. Okay, and you will be losing a lot of weight as well, but without realizing your exercise. That's what the experts are saying. Okay, so now the immersiveness is getting so into it. I think now you understand what I mentioned earlier in the presentation. the future is going to be more like Ready Player One kind of movie, because this is all we have seen it there. Now they are trying to apply everything right now. Okay, as you can see, this Omni, started doing this in last year in 2020. I don't know, the thing, they already released 2 versions of it. Probably by next 5 years, I think they will reduce the size of it so people can be able to enjoy this anywhere they want. Aerodromes, when you are waiting for a aircraft, when you are actually in the railway stations, who knows it? Okay, you could able to enjoy these kind of immersive environment no matter wherever you are. That's what they are trying to achieve with this. So commercially, this is going to be a huge hit when it comes to gaming. Now, in military and practical training as well, virtual reality will bring you the immersiveness and so close to realism right in, to wherever you are. So what are the advantages of these applications? You are not losing any life, number one. Number two, a lot of virtual bullets, everything is being used. So you are not actually using the resources. So the pollution is not there. So these are the advantages from there. Okay, but you are actually trying to get to into physical fitness, and also get to know the realistic situations without heading into one. And the pilot trainings, for example, NASA is mainstream. I'll tell you one, guys. I'll tell you one thing. Virtual reality is commercialized now, but it was very virgin. The virtual reality technology was used in high, what do you call the sophisticated companies like NASA and other ones. Okay, because it's not commercialized, they developed a lot of simulation parts. When I say simulation parts, it's more like a dedicated area where pilots will get trained without zero gravity. Okay, how to operate a rocket and how to, they can able to simulate their moonwalk. Okay, and all this kind of technology was actually applied to them by NASA. Then virtual reality has been brought to us by Oculus Rift, now procured by Facebook, and the rest is history. Okay, but I just wanted to let you know that everything started in sophisticated companies and training alone. Now virtual reality is used for entertainment as well. Now, virtual reality demands highly configured systems and defined space to enjoy the technology. This is what I'm talking about. Okay, so not all of us can be able to afford to any of this at the moment, because these technology is still kind of expensive. All right, so take a look at it. When I say mainstream VRs, these are the devices that, please do not think that okay, it's a simple technology to put in. Basically, this is one of the simulation I was enjoying in VR Hub in Vellore. I think the CEO of VR Hub will be talking to you the same time tomorrow. But what I'm trying to say here is it actually consists of an outside tracking, okay, which tracks my position, okay, my head and all everything from outside, okay, and it has inside out tracking, which is my HMD, okay, and there should be a very tight correlation between my outside movement and the inside movement. Why is that? Is because then only the system can able to detect where exactly you are in a 3D space. Okay, so both inside out and outside in is extremely needed. Hand gestures tracking. Okay, there is a separate device which will gesture my rotation, okay, and the total gimbal, okay, of where I am actually having my hand. Then the simulation processing medium is most probably a very high sophisticated graphics card and CPU, and a confined clear space. This is extremely important. Okay, why? Because you cannot be standing in a congested situation where you will be knocking down other people's head. You might actually go for VR funny videos in Google, YouTube or something. You can be able to see that people used to fall often, or they punch their own TV with their own hands, causing fatal damage to the TV or anybody else who is there, because they don't know how they are reacting in the physical world, because they are so busy in the VR world. Why did I show you this? Is because this is the minimum setup for a very sophisticated virtual reality device to work. By the way, if you are wondering what device I am wearing or using right now in this picture, it's HTC Vive, which is one of the mainstream sophisticated VR device available in the market. Now, coming back to the augmented reality, that's enough about virtual reality. Now, how augmented reality simulation changes? Okay, I think one of the question also we wanted to talk about AR. This is a non-immersive. I think you now understand the word non-immersive because we have seen what is called immersive is. Non-immersive is you will be still connected to the physical world you are because there will be some superimposition of things on top of it. Your smartphone is enough to enjoy augmented reality. As I mentioned, this is a huge thing that separates this simulation technology from VR. And that is why many companies are concentrating on AR first so that this will be implemented easily among the population because of this, our smartphones. Okay. Now, to put it simply, VR is actually a world, okay, works by deploying virtual images over real world objects. The overlay is executed immediately with the input received from the camera. Very simply said, augmentation is a word that stands for altering something. Your actual camera feed coming from your smartphone camera is altered by some man-made, in the sense what man-made is a wrong word, like virtual objects that we designated according to the location of what you see in the camera is what we call augmented reality. So when you move the camera according to the new position, okay, in real time, the virtual objects align themselves according to a camera feed, and that's why it looks very real to it. Now, that's the point I wanted to insist. The AI technology, so AR technology brings virtual objects into the surrounding environment. Now, AR is going to be our lifestyle. How? Well, we'll quickly see this.
Look around. Technology is all around us. We use it in every aspect of our lives. It enables us to do amazing things. But what if we could go further? What if we could go beyond the screen? Where your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
Okay, so this is this video shall run for another 4 minutes, which we don't have the liberty of time in here. Okay, so what I'm trying to say is this is a promo video from Microsoft HoloLens, which is an augmented reality device. If you think about it, virtual reality devices are being manufactured by several companies, including Lenovo, Oculus, now owned by Facebook, and several other companies. But Microsoft, being a giant, okay, is not coming into this virtual reality manufacturing process. If you think why, because Microsoft knows very well that augmented reality is the one which is going to take the world by storm. So what they have concentrated now is in their HoloLens, which if you think this can be real, well, take it from me, it is real, okay, because it has a terrain scanning system where the moment you actually wear the HoloLens, You are connected with your environment, and the artificial intelligence scans your environment like tables and chairs, and it forms a 3D terrain inside where it knows which place is elevated, which place is the floor. So it puts the virtual objects according to your real environment wherever you are, where your brain straight away accepts that as real. Okay, you can only understand my words when you try to experience that. But fortunately, you don't have to wait a long, because the HoloLens 2 has been released like 2020 December. And because of this pandemic, we are not exposed to most of the technologies. Once everything is done, like 3 or 4 years from now, we will have very easy reach to these kind of technologies. Okay, so this is a HoloLens project. Okay, and as you can able to see, AR is going to be everywhere. Okay, and this is manufacturing and guided instructions. Okay, how many times we need to actually call our plumbers, okay, or the electricians to actually, even for a small problem it might be, but we are afraid not to fool around with any of the electronics. So what this can be done is using augmented reality. A person, if you have seen the video as well, a person can able to instruct you. Even that person can be overseas, it doesn't matter. That person can able to give you guided instructions on which knob to turn, how much to turn, which lever to pull, and it's going to be easy peasy. All right, so this is one of an amazing application of augmented reality. And tourism and travel. Okay, when you actually go to the very popular street, okay, in Google Maps, and you don't know where to go, all you have to do is pull your smartphone, open an augmented reality tourism application, show the street with the camera, and it will actually pop you up with all those information you might need in order to navigate to that area. Okay, so what is a hotel? In fact, I have seen one application which is more sophisticated, that shows you how many rooms are left, how per night, how much they are actually it's costing you, all this kind of application. There are a lot of applications available. Google Street View have adapted this already. So any company that have a collaboration with Google can able to give you this technology. Medicine, I don't have to say this. Okay, it's so difficult in education and training. These kind of subjects, okay, you cannot fool around with people's life. I don't know how difficult for them to teach them with real organs. You know how it is happening in medical colleges, right? You literally need to have a corpse in order to teach them the organs and all those kind of things. Now, before you go into that stage, all of the whole class able to give can be able to provide it with a ultra realistic. Okay, when I say ultra realistic, trust me, it is. Okay, a very ultra realistic simulations has been given to all these kind of medical students. Okay, as you can see, this student is actually having a Microsoft HoloLens, because this is one of an advertised area of Microsoft HoloLens. You can search in the internet later, you will see most amazing real videos. I'm not talking about graphics, how much it helps the students to go through their studies, especially like piloting, welding, chemical, like chemistry, and these kind of medicines. It's a boom. Commercial purposes, how many times we actually had a problem in buying a furniture, whether it fits or not, whether the color suits our wall, how much space it would take, whether it is life size or not. See, when you look at the pamphlet, a sofa that looks real so nice doesn't actually look the same when you look at it, or after buying it, then you figuring out the size is not fitting your room, especially the air conditions, okay, and microwave ovens. Literally happened to me. I thought, okay, this space is enough. I bought an oven of like 15 liters. I came home, I was unable to fit inside the shelf. I have to go back, a lot of hassles. But now AICTE, okay, so they have actually come up with these kind of applications where you can able to go through the catalog in augmented reality, show the camera wherever you want to keep it in your home, and it, mark my words, it's a real size. Okay, it's life size. Okay, and they actually start to ask you to show your walls and all first. So you will be looking at, it will be detecting all the real life sizes first, Then it will adjust all the 3D objects according to your home size. This is one commercial one. And just last example, I want to show you how much AR can be commercialized in the future. VR AR used in jewelry industry. Yes, Regina Mall, ma'am. Yes, this is almost same kind of example. Take a look at this. By the way, this is used Microsoft Kinect technology, which is a motion detection device. Those who are very fond of clothing would understand what I'm trying to say here. How many times we have actually been waiting in a fitting room, holding the clothes in our hands, especially in celebration times like Christmas and Diwali. These kind of times, there is a huge crowd. We have to wait and we need to wear it. Well, I'm not saying that the augmented reality can give you the feeling of the actual wearing, but take a look at this.
Show me skirts. Yes.
Okay, once she actually is happy with the collection and whether it suits or not, it gives you a QR code. That QR code, when you scan it with the application of that shopping center, it's straight away added to your cart. Even if you want to buy it, you can pay with your mobile phone and leave the shop without even going for any of the take your cloth, and you can able to go. Of course, there are detection services for handling the thievery, but the thing is, basically, this is how it works. Okay, well, now when it actually comes to the question, okay, this is fine, Suren. If your question is, there is one thing you cannot buy online. I didn't say that. My mom used to say that. I show you this. Okay, just another day at home, literally did that. Okay, come on, Suren, you guys just cannot buy everything online. See the hassles we go through of returning due to ill sizes, because I'm 6.3. Okay, and you know how difficult it is to find a t-shirt for me with proper length. Okay, clothing and shoes, forget buying online. My mom is not against online. She buys a lot of things online, but she never buys shoes and clothing, because right, you will not be happy until you wear the shoes and walk a couple of steps. Normally happens, right? But I used to tell her, you are right, mom, but sorry, mom. Okay, why? Because we have been given Zozo suit. It's a Japanese tech. Okay, quickly show this. Okay, this is a bodysuit that is given free of cost by Zozo company. Okay, it comes free of cost when you register. All you have to do is, it's a very spandex kind of thing. I don't know what the material, you guys already know. Okay, you need to wear that, and they have a specific app. You stand in front of it. Since it is actually showing the contours of your body, your body sizes are completely converted into an AR size management software. According to that size, you can able to buy clothing online, because anything that does not suit you will not be shown at all. Okay, in your application. Like take Myntra.com. You're buying your clothing from Myntra. see how much time you need to waste by going through it, filtering through our sizes and all. But this augmented reality application, what it does is they give you a free suit according to your scanned thing of your body. They will actually show you all these things. Not only that, shoe as well. Take a look at this. Okay, the application detects the size of the actual, can you see the measurements are razor sharp. Okay, when I say, because it has a predefined value of the chart, when you put your legs on it, 360-degree photograph, okay, it will ask you, once you take that, software puts everything together to find out the actual size of your clothing. And see the match, 93% match with your size, 98% matches. And this is how the scanned 3D model is superimposed on your own body. So what happens now is, buying clothing and shoes online is going to fit. Okay, so probably the company is saying hereafter we will not get any returns for ill-fitting, and actually they did that. Okay, so they are not receiving any ill-fitting complaints anymore. Only the colors looks different, all these kind of things. But fitting, as far as they know, it's almost next to perfect. Okay, so that's the Zozo suit. Again, augmented reality. These are few examples I wanted to show you. Now, if your question is, okay, everything is super cool, fine, thanks for your time. Is this technology affordable now? That's the question to us, I mean. Well, basically, it depends. Okay, how much does mainstream VR systems? Now, this is, I have taken it from December 2020 and January 2021, but the price still is the same. HTC Vive kind of devices will cost you almost 1 lakh. Okay, marketing gimmick, 1 rupee less, 99,999. Okay, and Oculus Quest is the latest standalone. When I say standalone, you do not need a system for that. It has its own battery. It has everything. You can, anywhere you are, you can buy, you can wear it and you can enjoy. Even in airports and outdoors, it doesn't matter. But you know what? Its quality is limited. When you connect with amazing CPU, the quality is entirely different. But this is standalone. In other words, portable device. Cost you around 84,000. Oculus Go is a previous version of Oculus Quest that is around affordable of 3,799. I actually bought Oculus Go for 34,000 when it was released. Unfortunately, I don't have it with me. Okay, I think Martin sir knows in my previous presentation, I was actually somehow like last year showing that, but I couldn't do that because it's not with me anymore. But I found other things to show you. Okay, so that's Hope VR hardware. Google Cardboard is there. You don't have to spend any money, more than 300 rupees to enjoy this. Made VR available to everyone. Actually, Google's Cardboard technology is one of the reasons why most of us now is aware of virtual reality and augmented reality. This is a Google Cardboard, literally a cardboard which comes to you. Okay, it was free of cost before, but not in India. In US, you can order it for free of cost. Okay, in here, there are a lot of other companies who are actually doing the same. This is a DIY, do it yourself. You can bend the cardboard, they will give you the Fresnel lens into it. You put it over there, put your cell phone inside, up and running, you are done. Okay, you can able to buy for nearly 200 and 250 rupees. Same technology of Google Cardboard given you in a plastic, easy to wear, more sophisticated thing. Okay, like Process and all these kind of companies, you can able to see. For example, you can put your cell phone inside. As you can see, there is a cell phone here. Same cardboard concept, but easy to wear. It's more like a sophisticated device, but it does not have trackers or anything. Your mobile phone is everything. Best places to get started with augmented reality is Google Play Store, where look for this icon called the Google Cardboard application, available for Android. I'm not sure about iPhone. YouTube 360 will allow you to enjoy amazing 360. The VAT demo I showed you, those kind of videos and augmented reality you can enjoy with YouTube 360. I think the previous presentation, the ma'am was explaining about Eon XR, where you can able to develop things to your students. Okay, this is a very best places to get started with. And developing your own 3D content, you can able to download 3D content for your subject specific models. For example, I'm a mechanical teacher. Where can I get a car engine? I can able to go to these websites. I can able to download. Some of them are free. Some of most realistic models are kind of expensive, like $200, $1,500 even. Your human body with the nervous system working human body, it actually costs you that, okay, that much, like $1,300 and all. Your institution can be able to help when you are doing it for the whole thing. Okay, what I'm actually want to tell you now, after this next slide, I'm going to show you a very quick demonstration how as a teacher you guys can able to implement virtual reality in your classes. Okay, that's what I'm going to tell you. So what's next in the future we are looking at? We are looking at remote touch and feel, hyper real movies and games. What we could do now, we will be looking at like this in the movie theater. Hereafter, we might be able to smell, okay, like 7D theaters you have seen. We will be able to feel the vibration when something explodes, when somebody, you know, whatever the scene, according to the scene. So they are actually adding more dimensions into the movie. Telepresence meetings. A whole global virtual society might be formed in virtually. Like for example, a conglomeration of countries where you can able to live your second life. Okay, if you have time, go and Google second life. You will be amazed to see there is a virtual society available already. Okay, so this might becomes mainstream in the year to come. So sit tight. In the near future, it's going to be overwhelming when it comes to augmented reality and virtual reality. Now, before I get into it, actually, I know, first of all, I need to thank for your patience that you guys are sitting around, you know, just hearing to what I had to say. I think I did not bore you so far. So thank you for that. So let's quickly go ahead and to get into the demonstration. And I will try to finish it in maximum, it's 12:46 now. 1 o'clock or 10 minutes after 1 o'clock, I'll try to stop this presentation. So we will have our Q&A, then we'll all break for lunch. I mean, if that is the schedule. I'm nobody to tell the schedule, just saying. Okay. So what is the software or web-based tool I'm going to use? I'm going to use the website called CoSpaces EDU. Okay, it actually brings the augmented reality and virtual reality right inside the classroom. Okay, so if you're in your laptop, simultaneously what you can do is you can create a username and password with CoSpaces. It's absolutely free. Okay, it will ask you, when I'm going to click on register, it will ask you, are you a student or a teacher? So of course, you guys go ahead and click the teacher. It will show you the agreement document, just the usual thing. Accept the agreement, create your username and password, and it's free. Once you have done that, you will be taken to, okay, this, for example, this is the login that I have. For example, I have created an account specifically for this. Okay, Suren et al. Okay, I'm going to actually give this login to you. And also, CoSpaces provides two versions of logins. One is professional edition, which you need to pay money. The other one is free of cost. The only difference between professional edition and free of cost is your class cannot have more than 30 people when it comes to free edition. But when it comes to professional edition, your class members, for example, your students, there can be more than 30 up to 100, okay, or even more than 100. Now, what I have done is, I have talked to these people for a specific purpose, and I took a 30-day trial of 100 people occupancy. Okay, as you can see here, I have created it, okay, yesterday, July 8th. So this trial will be active until July 8th, 2021, and seats occupied is 100. Okay, so what I'm going to do now is I'm going to create a class. The class name I'm going to give VR AR ATAL AICTE, okay, Karunya, like something, okay, create. This is a class, okay, and this is the code that you would be using. For example, if you have a student account, okay, you can join this class by using this code, okay, and your class, you can able to enjoy CoSpaces until July 8th, 2021, 1 month from now. That is more than enough. or if you don't want any of this, create your account separately as I showed you, register your email address, your account, and have fun with it. There is no restrictions unless and until you want to add more than 30 students to your class. Okay, I'm going to copy this and put it in the chat window. CoSpaces class code for up to 100 participants. Okay, so I think that, oops, there is a spelling mistake in CoSpaces. Please bear with me. Okay, that code you can able to apply when you are registering as a student, and you can join in my class straight away. You can assign assignments to the students here. The registered students will be shown here. The teachers will be shown here. For now, I'm the only teacher in here. Okay, how to manage a class inside a CoSpaces is not the topic now. I'm going to tell you why CoSpaces will be effective. Okay, let me actually take you to the CoSpaces. On the once you log in, you will be shown these 4 gallery classes. If you have any classes, you can go inside this. CoSpaces, your own very own space inside your login where you can able to have fun with. Okay, go to that. Archive is, if you lost your trial period, all your work will be gone to archive. Okay, when you open it for the first time, this is the CoSpaces by default will welcome you. How to look at the CoSpace? Click that. It will load. All these CoSpaces are virtual reality and augmented reality ready spaces. Okay, can you see this is a development stage? Okay, this is a development stage where you will be building the applications, like for example, snapping. You have the library here. Okay, all these things. Okay, I will show you pretty quick. But to enjoy a CoSpace, you have to select your play button. That will be playing, the experience will be played to you. This is when I select play button. See, now it is what? Hang on a second. I moved the camera, it seems. Okay, select on play. Okay, now you can actually go to 5 scenes. All right, you can move. All right, it's loading right now. Internet is kind of slow. As you can see, it's giving you a tutorial of how to moving around in CoSpaces. Like left click, you can move around. Okay, hold the space bar and click drag to move. Okay, like this. And scroll to zoom in and zoom out. This is a tutorial that comes with it. It's real fun. Okay, click on this mouse and V to center it. Okay, click on the mouse in here and press V in your keyboard. Okay, guys, my system is extremely slow. Don't take it wrong. Actually, this is a very, very easy software. Since I am actually using Zoom, like I've connected a lot of things, and it's just a laptop. Okay, so the thing is, I'm trying to zoom with the scroll bar. Okay, but when you enjoy it, it will be really, really easy. Once you have to go back, select this on the top left to go back to your scene. All right, and press on home button on the top left to go to your CoSpaces screen. Now, what I'm actually going to show you is, as a teacher, you can be able to create these kind of engaging, guys, the word engaging, trust me, it works. Okay, this kind of approach as a teacher to your student will keep them in the edge of their seats when it comes to, because you cannot express your feelings and your, physical gesture that you cannot give in an online education. At the time, these kind of tools will really help. Take it from me, I have done 3 publications on the same topic using visual code and the engagement factor between different students when it comes to this. And as a team, we have actually seen the engagement levels of students have really gone sky high when we actually give exercises in these kind of highly engaging environments. Okay, now I'll tell you one thing. I'm going to imagine that you are a mechanical teacher or like a media person like me, for example. First of all, what you need is you need to create a CoSpace so that your students can enjoy. How to do that is create a core space in here, create core space. It will ask you what kind of core space you want to create. I'm going to say empty scene, but there are several things that will start you with the starting point. For example, a portfolio, large gallery, poker game. Okay, I'm not going to touch any of that. I'm going to go for a clean scene. There is one technology in core spaces called merge cube. Merge cube is you need to buy, okay, the cube to enjoy for the augmented reality. I tried to buy one. Actually, they said they cannot ship it to India at the moment. But I have a cube for my class separately in VIT. Okay, but I don't have it right now. If you want to use augmented reality, you can use merge cube, but now you can use an empty scene. And the empty scene is loading. Okay, this is an empty scene. This is the camera. Okay, now see, this is how the view will be. Okay, this is a designing phase. So what you see here will not look at the same thing when you play the game or when you play the environment. Now we are building stuff. First of all, take a look at your environment. There is a sky, and like other software, the space given to you is infinity. There is no starting, there is no ending. You can able to bring anything that you want. Let's start with the default assets that has been given to you. Take a look at here. This is a library. Okay. And one of the things that you can have here is you can bring in characters. They have animal categories, housing, some miscellaneous items, transport category, nature category, building primitive items, some special items like camera, or you can use a search button to search what you need. If it is available, it will show you. Now what I'm going to do is I'm going for the characters. These are the characters that is having here, and you can scroll here and you can see this is a pro version. If you join my class, you get access to everything inside CoSpaces. Okay, they have given everything. Now I'm going to use one character. How to add elements to the scene is very easy. Click and drag that guy to wherever you want. And it's a complete 3D object, and it now for now it is not reacting. Press the play button. Can you see it is automatically animated as idle? Okay, as you can see, this is a VR environment, guys, by the way. The CoSpaces application is 100% free for your students to enjoy in VR. Okay, in your mobile phone, I mean. Okay, so you can, what happens now is you can give behaviors and character to this character. How? Select the character or right click on the character. The name, it says Roman soldier. You can change the name anything you want. Okay, it doesn't look like me, but anyway. Now, if you take a look at it, it has a coding component where you can actually use visual coding. I'll come back to the topic right now, just a few moments from now. It can able to speech, you can able to say things. It can react to physics. You can transform it, you can animation it. For example, go to the animation. Now it says attention. You can actually go and choose any posture you want. For example, defeat. I'm selecting the postures as defeat, and now I'll go and check. Now the character is sad because it's been defeated. Okay, now if you go here, I think you getting me. The animation, reactions, clap. Can you see? Now it is clapping. It's hilarious to see it's clapping with this. But basically, guys, this is what I'm trying to say. All these characters, assets in CoSpaces you see are controllable and customizable. Okay, they can be customized. Okay, I have lost power. I believe what I do is I'll just 1 second, I'll switch off my video. So I need to connect my camera because I'm using mobile phone as my webcam. Okay. I think now it is, yeah, cool. It's charging right now. Let's switch on my video. Yeah, I think the position is okay, I believe. Okay, I changed it. Can't keep it. All right. So I think it should be okay. Autofocus that. All right. So coming back to what I was saying, by the way, these are all programmable. But when I say programmable, don't think that you need to learn a programming language. Guys, it's a very simple, neutral pseudocodes. Before I go into that, I need to tell you what is called a pseudocode is. A pseudocode is a general instructions that can be converted into commands. For example, how to make coffee. If I ask you that, what would you say is the programming steps? Okay, or how to make tea, because I don't know much about making coffee. All right, how to make a tea. Switch on step 1, switch on the gas stove. Step 2, pour water into a vessel. Step 3, keep that vessel with the water on the stove, and these are pseudocodes. Okay, and there are some conditions. If water is boiling, then pour the tea powder into it. If the tea powder water is boiling, then filter it. See, these are basic conditions, if conditions. How to implement it inside these kind of situations? Now let's go ahead, okay, and go to this specific area called code. When I press that, there are two things the CoSpaces will support. One is CoSpaces' own proprietary co-blocks coding or scripting. Scripting can be any other third-party programming languages. I'm going to go for co-blocks. Select co-blocks. Can you see these are more like a Lego building sets that you can able to drag and drop. This is very intuitive programming, and my students actually loved it because it will never throw errors in your face. Number one, that's why people hate programming. Number two, missing comma, semicolon, no problem. Okay. So the thing is, it's fun. It's a lot of fun. All of them are event based. What are event based? If the door is closed, then. If the door is open, then. If the character fall down, then. If the character is clicked, then. So all of these kind of commands are event based. So we can make our CoSpaces code really interactive. Okay, I'll show you a very simple example. When play is clicked, what is play is clicked? This means when somebody start the CoSpaces game or program, that is a default one. You cannot remove this. What they mean is when somebody click the play, when somebody opens the CoSpaces, what to do? Nothing to do. What I'm going to do is I'm going to program this character right now. How to program this? Right click this character. First of all, you need to tell CoSpaces that you are going to use this particular character inside coding. For that, select the character you want to control from the program, right click, click on code, switch on this option that says use in code blocks. Yes. Now what you can do is you can use that character in here. Now what I'm going to do, I'm going to set a condition. I'm going to set a condition like, see, these are the different conditions you can see: events, control, operators, items, data, and functions, and so on. I'm going to go for events. When Suren is clicked, because I have named this character Suren, is showing it, or else I say Roman. I'll change the name. Can you see everything is changed now? When Roman is clicked, what to do? There is a space. I'm going to drag and drop it here. So this is the flow. This is how the program flow. The first one is when play is clicked, then when Roman is clicked, when somebody click the character, what to do? You need to put that in this space. I'm going to go for actions, set animation of Roman to, don't animate, right? I'm going to drag it here, set animation of Roman to fight attack. So when you click the Roman, he will react to it. So let's go and check whether it works. Play. Okay, I got the power back. Super. That character is clapping right now. What I'm going to do is I'm going to click. The moment I clicked, he started attacking. Can you see? So now this is a very simple condition. Okay, or delete it. It's as simple as deleting it. I'm going to go for transform turn Roman clockwise. Okay, can you see? I'm going to use this. When Roman is clicked, I'm going to turn Roman clockwise by 190 degree in 1 second. If you want to turn it slow, it's very simple. In 5 seconds. I'm going to play. Guys, you don't have to type a single word of thing. I'm going to click this guy. Can you see? One time I clicked, 180 degree is slowly moving. If I click again, it's rotating again. Imagine you can able to give exercises and exploratory assignments to your students using something. You can build a scene out of it. Okay. And by the way, this is not the environment you want. You can go for the environment here. Select your environment. Okay. Click on edit. You have this much environment available for you. For example, I'm going to click on this mountain. Voila. Okay, you have an infinity mountain space, or if you want a room kind of thing, you can go for this. If you press the play button, you will see that this character is standing inside a room. Okay, this is, imagine you can able to enjoy this in VR. That's gonna be amazing. Okay, for now, actually, you just go for anything that, even a moon we have. Okay, so moon environment. So anything you can do. Now, I showed you how to add things from your library. Okay, can you see these are the characters that are available? Transport, you can drag and drop a cycle you want, a car you want. Okay, and you can actually animate the car, animation, all closed. Driver's door open. Okay, the animation is, I'll press the play button. Okay, and you can use WASD key in your keyboard or arrow marks in your keyboard to travel through the VR space. Same can be done by swiping in the CoSpaces app if you are using in virtual reality. And default animation of this cycle is pedaling. Okay, you can change this behavior on actions or by default, however you wish. Okay, this you can able to do. Now the question is, okay, I'm a faculty of electronics communication engineering. I want to show how a rheostat or something else in action to my student, or I am a mechanical faculty. How can I able to give an assignment or an experience design using a diesel engine or a car engine? If that is your question, what you could do is, the only need you need, I said the same thing, the only need for you is to bring a 3D model inside this CoSpaces. How to do that? There are several ways. People like me, for example, I am a 3D modeler myself. So whatever I need for my class, I will model it from the scratch. But the thing is, we cannot expect all of them to be a modeler as well as teaching some other subjects as well. In that case, there are several websites in the internet, as I showed in my PPT, allows you to download ready-made 3D models. Some of them are TurboSquid. Okay. TurboSquid. You can able to search for free models. Absolutely. I'm not asking you to download or pay money. You can go for car engine. If you wait for a while, all realistic models in 3D animated as well is available for you. And what you could do is, you can go for the price you choose free, formats you choose. I'll show you. I'll go back to CoSpaces. Guys, I'm going to close. Oh God, I closed that as well. Because my system is getting really slow. In here, you can either use from library or the environment you can change. You can upload your own 3D models. If you select your upload, it will show you, are you going to upload your own images, videos, or all files, or what kind of thing, or sound files. Here 3D models is available. If you see the 3D models is selected, you can upload only OBJ file with material textures, or you can upload FBX or a zip file. My suggestion is, in my experience, first choice, go for FBX. FBX is a proprietary format from Autodesk. FBX stands for film box. That is the most sophisticated format when it comes to distribution. Go for FBX. If you cannot find a model in FBX, go for OBJ. Never go for any zip file and all. It never works. Okay. Now, so since we know now that so show the slide once again, which had the links to download and content. Yes, Lalita ma'am, I will show. Just 1 second. Here. Turbosquid.com, archive3d.net, free3d.com, sketchfab.com. I'll tell you one thing, just go for Google, type free 3D models. Definitely you will get these websites right inside. You will get a lot more, but these are the 4 tested by me in my experience. So I given this. I think you guys took note of it, or else I will show it again, no problem, during the discussion phase. I'll go back to this. What I was about to show, yeah, the 3D model downloads. Okay, one thing I want to tell you very quick, there is a website called Google Poly. Google Poly is more like Google Images, where you can download 3D models free of cost. Unfortunately, they are trying to shut down this from June 2021-30, which is we have 21 days more to use this website if you want. This is an amazing low poly models. Guys, the models needs to be lesser in polygon count so that it will not be so heavy when you are using with this one. Okay, so what we're gonna do is I'm going to search for engine. See, you have given a lot of models. Okay, so what I did is this morning, can you see here, torque in car engines, this model. By the way, everything in this website is free. So before June 30th, if you have time, download all the models you want. Google will never ask why. Can you see this is animated? Before you downloading, you can enjoy, okay, whether this is suitable or not for you. Once you are done with it, go for the download button, which is here. Okay, click on download button. It will ask you what is the format you want to download. I already told you for CoSpaces, FBX is a very good format. So click FBX file and that will be downloaded to your computer. Once that is downloaded, as you can see, I have the downloaded one in here. This is the downloaded file. It comes with a texture and it comes with normal maps. Don't bother about this because when you use this file, all this texture file will be used along with it. torqueincars.fbx. By the way, this is 16 MB file, which took me a while when I uploaded. So what I did is I already have a CoSpace where I have uploaded it. Go to the home. Can you see this CoSpace? By the way, you can create any number of CoSpaces in your account you want because you are using my this thing. See, already 5 people have joined using my code, as you can see here. So you people can able to enjoy this pro version for next 1 month. Afterwards, if you like it, you can buy it, or you can tell your institution to buy a license for you. It's not very expensive. Go to CoSpace, the one which I had it this morning. You know how I brought it inside? Very simple. I went for upload. I went for upload button and I selected the FBX file. The 16 MB file has been downloaded here and I actually dragged and dropped it like this. I did not do anything else. Okay. By the way, you can change the color of the material you want. Right click the model, any model. Go to material, change the color you want. Any color you want. This looks really nasty, so I made the gray color. Okay, now you can rename this model anywhere. And if you're wondering it is not rotating, you need to play. Then you need to see. Imagine as a faculty of mechanical engineering, you're giving this piston system to your students to explore. Then on top of this, you're asking questions. Imagine about the retention rate they might have when they actually experience this in virtual reality. Now I am in desktop, but when you are in CoSpaces application, I wish I could show you that. If time allows, I'll do that. Okay, so you can bring interactivity to it. For example, I'm going to use this in the coding. For that, right click this, go to code, switch using co-blocks. So this can be used in the coding. Go to the coding. When play is clicked, I'm not bothering about it. I'm gonna say when my model is clicked, when Tarkin cars. Why it says Tarkin cars? Because that's the name of it. See, Tarkin cars. If you want to change the name, you can change it. I don't know, guys, please bear with me. I don't know about this technical terms. I'm going to say pistons. I don't know even whether it is a correct name. The moment I do that, can you see that the pistons is being changed? My system is slow, or else it automatically will be changed. When piston is clicked, what do you want to do? You can do anything. You can start the animation, or you can stop the animation. You can rotate the pistons. You can rescale the piston. What I'm going to do now is, I don't know what I'm going to do. I'm going to say, piston say hi for 2 seconds. What I'm going to say is, piston say, hello there. Please explore me. Please explore more. Play button. See, hello there, please explore more. When you click, it actually says that. All right, so literally, guys, there is impossible combinations you can able to make out of this. Okay, since the time is of essence, I cannot show you all the possible combinations you could do. So I'm choosing, or the events, when piston is clicked, I already have that. What I'm going to do is, probably I might find it very quickly. I'm going to say here, turn or rotate. I'll start typing. Here. Turn pistons clockwise by 180 degree. I will say 90 degree. See, it's very like childish. It's going to press the play button. Now the piston is running. When the piston is clicked, voila. Whenever the user clicks in virtual reality, it actually rotates it 90 degree. Your internet connection is unstable. Oh my God. Okay. Sorry, I'm using my Geo, this from the mobile. Okay, so this is what I wanted to tell you about CoSpaces. It's really engaging. Okay, CoSpaces applications can be downloaded in Android phone and iPhone, and it's free of cost to use. All you have to do is just log in with the same username and password, and you can see your CoSpaces there. If you have students in your class, you can provide an assignment to all of them, ask them to experience it, and write notes on about their experience. Trust me, it really worked. Okay, if I can able to log out from here, I can show you all the work my students have done in the previous semester and even before that. Then you will understand what is the potential of CoSpaces. Okay, for now, before I lose my internet connection, I think I should stop right here. So I'll be open for more questions because it's 1:17 already.
Hello.
Okay, guys, thank you so much. I can't thank you enough for your patience with this. I tried my best to keep things simple. I know I rushed a little bit at the end, but there are too many things I wanted to tell you. So I hope I gave you a glimpse of what can be done in this session. All right, I'm stopping right here. I'm open for Q&A.
Hello.
Yes, ma'am.
Yes, ma'am, you can ask questions.
Hello, sir. Good afternoon. This is Dr. Aarti here. Suren sir, this was amazing demonstration as well as very interactive as well as informative. I would like to ask one question. I really like the way you have put up the slides. Amazing. I really like the quality.
Thank you.
And I'm from IIT Bombay. One of my junior, he is head of the department in Vellore IIT, design department. His name is Salim Ahmed.
Oh yeah. Yes, ma'am.
Okay, you know him. Yeah,
Yes, ma'am.
he's just 1 year junior to me.
Oh, great, ma'am. Great.
So I just wanted to ask you one question. That's in CoSpaces. Can we edit the 3D objects? We can add up, or we can delete, or we can means add on few things. If I say this piston is having oil in it, in case, so can I add the oil in it, or no, it's not possible? I have to create on my own.
Ma'am, okay, thank you so much, by the way, for your feedback. I really appreciate that. To answer you quickly, for example, this particular model I downloaded, the engine, is not available in CoSpaces library. Of course.
You have taken it from the Google.
Yes, ma'am. I just showed, you remember, right? From this website.
Yeah.
So like this, you can able to download models if it's available for you. Okay. For example, these models are most oftenly used. Okay, and these are available. If you have specific needs, ma'am, you may have to use 3D production software such as 3D Automask or 3D Max from Autodesk software.
Maya.
Yes, Maya. In order to add any details that you want as a customized 3D model, and you can able to bring it inside. Yeah, you can use any of the 3D model as help for that. Or if you have a department of 3D production engineering, you can able to get their help and get it done well.
Okay. Thank you so much, sir. Thank you. God bless you.
Thank you, ma'am. Welcome.
Okay.
And one more thing, as Dr. Aarti asked, okay, before the next question, I just wanted to add one more thing. If you are wondering whether you can able to edit the 3D models that comes default from CoSpaces, you cannot actually you cannot edit them, ma'am. You can either use it in your scene or don't, but you cannot edit them.
Okay, and one more thing I wanted to ask, since I was watching you place that Roman character in the house structure somewhere.
Yes,
so I wanted to ask, a few things are still and few things are moving. So can we use some kind of time bar or something where this person is moving from, like how we can record, or we can record it the way it's moving, it's interacting, and a few things are still over there, or like two characters are interacting with each other on that platform.
Okay. You can, ma'am. You can. You mean to say, can you time code things?
Yeah.
So you can able to play and just watch.
Yeah.
Pretty much you can, ma'am. Well,
okay,
for example,
I need to explore, that's all, because I know that so many people must be waiting for the questions.
Okay. But I can answer you very quickly, because I'm not going to show you that. When play is clicked, is your first starting. What you need to do is remove the condition, ma'am.
Okay.
When Roman is clicked, remove the condition.
Okay.
Go for transform and move Roman 1 meter forward. Okay. In 1 second. Add it right after somebody press the play button, which means there is no condition for the movement. Actually, he is actually not moving now, because I said only 1 meter.
Yeah. Okay.
If you actually put an infinity symbol there, I put 0, that person will keep moving until you finish, you come out of the program.
Okay.
So if you want two characters to be talking to each other, put this character, say hi, then this character says hello. So like this, you put this one and press the play button, you can see.
Okay, and have to define everything.
Yes, ma'am. Yes, ma'am.
Thank you so much, sir.
Welcome, ma'am.
And please say hi to Salim.
Ma'am, my pleasure. I would.
Yeah.
Sir, can I ask question?
Please.
Yeah, sir. Very nice presentation. Thank you for that. And the kind of code that you are putting, like the drag and drop script, I think it's more or less similar to what Scratch is there, right?
Correct. Scratch, yes.
Yeah. So similarly, all those utilities are there, or I have not explored this yet, but or maybe just the UI is similar.
Sir, actually, this core blocks, the name is proprietary to this one, but the ideology has been derived from visual coding. So these are the visual coding. Scratch was a very, famous one when it comes to it, because Scratch, I think you worked with it. It can able to work on Macintosh systems, Linux, and Windows as well, and it's completely free.
Okay.
I believe that's because I have used in Linux the Scratch software.
Yeah, it's free. Yeah.
Yes, sir. So if you are aware and familiarized yourself with Scratch, the functionality is exactly the same. Only thing is the action words might change there. For example, here it says move. The Scratch might say transform. Here it says turn. The Scratch may say rotate. That's it. But ideology is exactly the same.
Okay.
Did I answer you, sir?
Yeah.
Shira, sir, did I answer you?
Yeah. Thank you so much, sir. This is one of the best session I have seen on this. I learned many new things. Yeah. Thank you so much.
Thank you, sir. Thank you. Oh, I have a really good session, sir. Which is better for future job? AR, VR, MR, or XR? Sankaran, sir, I would say you could start with AR because it's easy for you to implement now at the moment. If you are already familiarized yourself with AR, go for mixed reality, MR. If I want to proceed, what are the things I have to prepare? Okay, Shankaran sir, as I said, if you want to explore VR in your class, this is one of a very good starting space. That would really help. Okay, any other questions?
Participants, faculty friends, do you have any questions? You can raise hand and I can ask questions. Or otherwise, you can post the question answer session so that I will ask. Sir, one question has been posted in question and answer.
Oh, yeah. 1 second. Can we export like OBJ from models in CoSpaces to use in other platforms? Kavya Raj, sir, no, sir. CoSpaces doesn't support that because first, number one, it's a very good question. You can, if you have a custom model like I showed you, you can bring inside CoSpaces, and CoSpaces does not support you to export a model back from CoSpaces, and also you cannot export any CoSpaces own library of model that comes with it. You cannot use it because it's a pro version. It's proprietary to CoSpaces. You cannot export it to any other models. Okay. Any other questions?
Sir, this is true for pro version also? Like we cannot export anything?
Yes, sir. Pro versions also. You cannot export. In fact, sir, I'm using pro version. There is no way I can able to export any of the default models that comes with CoSpaces because it has its own animations, everything created by them. They don't support that. Thank you, Gangadharai sir. What is a cost matrix? The developers get paid well. Can we incline students to start learning the development? Well, the developers get paid well. Can we incline students to start learning the development? Dr. Shrikant Kavirani, sir, to answer this, the cost matrix that is available to use CoSpaces now is extremely less. Because you can able to download models for free, number one, and you can able to implementation is also free, and you can able to enjoy this on multiple devices, that is also free. But if you are actually end up in developing VR and AR based objects as a mainstream, then you need SDKs, software development kit. Those SDKs might actually cost you a lot, especially if you want to develop things in Microsoft platform in HoloLens. Their SDK, you need to have specific licenses, and you cannot buy for all the time. It's a subscription. You can subscribe for 1 year, then afterwards you need to renew. So for individual students, I wouldn't support that. I mean, now at the moment, but in the future years, we will have a lot of opportunity for that. Okay. So any other questions?
Dear faculty members, do you have any questions? You can post or you can ask, or else you can raise the hand.
Unable to thank the individual people. So thank you so much for everyone.
Thank you, sir. Thank you.
Thank you so much, ma'am, Marti ma'am.
Thank you. It was really wonderful session. I just wanted to know, like, though we've been reading a lot, and I did my PhD in interaction design and e-learning. So I wanted to know whether there are so many things. I was just discussing my husband. He is my husband is Salim's batchmate, and he's a typographer and calligrapher. So I was just asking him that metal typeface, which is not now obsolete, and that letterpress printing, which is now obsolete. So it can be created, that era can be created on these platforms and can be taught to the student. So, yeah.
Ma'am, actually, typography is one of the booming when it comes to UI design. I think user interface design, ma'am.
Yeah.
Typography is really booming. What you would able to do is you can design fonts. Before we actually design fonts for, as you get said, for lithography and all those kind of printing material.
Yeah.
Now you can able to design for specific applications. For example, in virtual reality,
Yeah.
in 360 environment, because of the Fresnel lenses, the corners of the VR will be always elongated.
Okay.
For that, what they need is they need a font that is bulgy in reverse. For example, like convex and concave.
Okay.
So you could able to design those kind of fonts. Because there are a lot of designers out there who are converting existing font designs into convex kind of thing, which means because if it is a font is normal, it actually shown like this. For example, now this one will look like this.
Yeah.
In VR.
Yeah.
What you need to do is you need to take this flat thing and you actually decide this way already, like this way.
Okay.
Like concave.
Okay.
Like this kind of design. So when it is displayed in VR, it's actually flat for you, ma'am.
Okay, wonderful. I'll just tell him. Actually, he has worked a lot for different languages, Indian languages, and we had our software business in Mumbai. So he has designed multiple fonts for different platforms, and from for printing to Samsung mobile phone. He created some fonts for them also, and in different languages. So and different scripts also, like Malayalam, I think so, and then Gujarati, Devanagari, Vedic fonts, because Vedic are different than having more characters, 200 some characters into it, and and Bengali. And so I'll ask him to do this because this is a new thing. He would like to do that.
Sure,
and we'll get back to you when we can, if it is possible.
Sure.
So from where I'm having your detail in that. Otherwise, I can search on the net also with you.
Okay. Ma'am, Salim sir is our dean actually. So
He's a dean. He's my husband's batchmate.
So getting in contact, reaching me is really easy.
Yeah.
Yeah, ma'am. So you tell him, and that might be a starting point. From there, we will see where it takes us.
Yeah. Thank you so much for that.
You're welcome, ma'am.
Thank you.
Any of the faculty friends have any doubts? Is it a time for winding up this session?
So just thank you so much for everyone for your patience, and Martin sir and Alex sir and the management of Karunia and AICTE. I would like to thank everyone so that I could be able to share what I know here. So I think it will be useful, and all the best and good luck in anything that you guys do. So take care.
Dear Suresh sir, thanks for your patience, and you have given a lot of things regarding the experiencing, collaborating, and usage of augmented reality and demonstration on post-based tools. Very impressive, and it is a lot of things we have gained from your 2-hour session. It's not like a 2-hour board session. It is very nice, and the time gone is very quickly. So anyway, in future also we do collaboration with you for this type of seminars, workshops, and conferences. Thank you once again, sir.
Thanks a lot, sir. Can't thank you enough for giving this opportunity. Thank you so much.
Thank you.
Thank you, sir. Surendra, sir. Thank you.
Thanks a lot, sir. So,
yes, faculty friends. Sir, please, sir.
Yes, sir. Okay. Bye, everyone. Take care.
Bye.
Bye, sir. Dear faculty friends and participants, it's the time for winding up for this session. So we have the next section by Dr. Subhashis Bhomika, so who have given into the first day, second session. So he is he is the one going to give into the next session. It will be sharply start at 2:30. So now it's the time for lunch. You can take refreshments and have a lunch break. Thank you. We will meet again at 2:30. Alex sir and Amit sir.
Yes, sir.
Sir, we will meet at 2:30, sir.
All right, sir. All right. All right.
All right.
Thank you. Thank you.
Professor, good afternoon. Professor, can you hear my voice? Professor, good afternoon. Can you hear
Good
my
afternoon.
voice?
Good afternoon.
Yes, yes. Professor.
Everything is fine.
Yes,
Program
yes,
is running
it's
smoothly,
going.
I think.
Yes, yes, Professor. It's going smooth.
We are getting WhatsApp informations. So everything
Yes.
we are finding its order like.
Yeah, we have WhatsApp group also, so it's easy to communicate everything.
People are becoming smaller, more smarter. Okay, nowadays, and systems is very
yes, Professor.
Very ruggedized type of systems. So only thing is that person has to know about this digital part. Forget about this analog. Go into the digital. Everything is coming in the digital. So you have you have to accept this one, and also at the same time you have to understand this digital process. Then the whole world will be in your hands.
So in a couple of minutes we will start, Professor.
Sure, sir.
Yes. Professor, today we have to give access to your PhD scholar.
Just a minute.
Yes.
Yeah, tell me. I think he requires the access.
Today also we have to give.
Yeah. Today also there is a hands-on.
Okay.
The demonstrations will be there. Practically, means 3/4 time will be of the demonstration type.
Okay.
With the access to the candidates.
Yeah, he joined.
He joined also.
Yes.
Yeah, he joined.
Yes.
So the master students and the PhD students, they are also working from home.
Yes, Professor. They are working from home.
They are working. And the faculty, they have to come, or no? They can work from home.
Work from home, Professor. Actually, 2 months back we went to college, and some important thing is the requirements. We will go to the office and we will do the work. Okay. But right now, due to the cases are very more, so we also working from home.
But it is completely locked down. Means the state has announced lockdown. No.
Yes.
Okay.
Yes, Professor.
Okay.
It is completely locked down, but a few things alone, in timing alone, they are opening and closing. Like grocery shops, supermarkets.
It's partially, but the office and all, this is completely closed.
Yes. It's completely closed.
Okay. And how long it will be for this month also? June also, complete June?
Actually, state government, they have given up to June 15th,
June
but
15th.
based on the number of cases, it may extend the proposal.
Means it is a tendency is increasing right now, or under control?
Yes, yes, Professor. Actually, in some areas the cases increasing, in some areas it is decreasing. So still now the government has not decided that to have the complete lockdown up to June until they have given the order up to 15th of June.
15th.
Shall we start, Professor?
Yeah, we can start.
Yes. Good afternoon to one and all gathered here. I hope this is the post-lunch session. It is very tough to listen, but anyway, this session also very much interactive. No need of this introductory about our resource person. We already have our Professor Subhasis Bhaumik. We already seen in the first day of this session. So I warmly welcome you, sir. I hand over the session to Lisa, sir.
Thank you, Professor Martin.
Sir, I am handovering to you the session. You can carry on.
Yeah, I'm sure. I hope this is visible. So good afternoon to all of you. And on the very first day, we started with this AR and the VR technology. And I hope that a lot of discussions has taken place so far. Okay. And mostly we will find that this technology is, what I say that this is practice-based technology. So only for the understanding purposes, what it can do and what it cannot do, or what is the level of this particular technology. So we have to go through some theoretical aspects. Okay. But unless and until we do some hands-on type of work, so it is very difficult to grab this technology, or it's very difficult to understand that how the things are happening and what are the steps, okay, that needs to be followed. And at least from the very beginning, in the last first day demonstrations, probably you understood that there are a lot of tricks are there, okay, through which we have to go through to develop a well-defined AR and the VR systems. So very quickly, I will go through the slides that we went through on the very first day. So we can recapitulate what we have discussed in the last class. Only for that purposes, I'm going through very quickly. I'm going through these slides. So that you can recapitulate that what are the slides we covered so far. So head-mounted display unit, AR display units, then binocular type of omni-orientations monitor unit, which is known as a boom unit. So these are the hardware setups. Then CAVE, automatic virtual environment, which is known as a CAVE. Okay, CAVE, CAVE, we see for CAVE, automatic virtual environment. That also we discussed in the very beginning. Then we had a input-output devices. We were discussing about these input-output devices which can be used for the AR and the VR system. And there we discussed about these data gloves, and I have already shown you the hardware setups, how a data gloves looks like. And if the time permits, I will show that how these data gloves can be used, okay, and for what purposes it can be used. So I have some sort of videos in our laboratory, some work we have done. We have developed some sort of dexterous hand systems, robotic hand systems, okay, which looks like a human hand. And then say for example, I have a left hand, I have a right hand. Okay, so how I can control my left hand with the instructions from the right hand. So what I can do, I can wear these data gloves on my right hand, and then if I operate my right hand, then definitely this will have a 1:1 correspondence with the left hand. So whenever there is a movement of the right hand, so the same movement will take place in the left hand side. And this technology is practically, it is used for communicating with a robotic type of devices, autonomous type of systems in a nuclear power plant industries. Or generally, this technology is used for the hazardous environments. These are the softwares, commercial software tools, CAD modeling software tools, which looks like an virtual reality environments, virtual reality models. So one can use these Unity 3D, then VREV, VRML, Wayboards, Gagebo. So these are the professional software tools which can be used for making the virtual models. Then we discussed about this technology that, say for example, what is the utility of this AR systems? Okay, so in AR systems, say for example, with the help of the AR systems, we can make the holes at a perfect locations on the wall. So for that purposes, we can use this AR technology. These are the sectors we discussed. Okay, healthcare, engineering, real estate, retail, military purposes, educational purposes, videography, live events, okay, and then video entertainment purpose. So these are the, we can say that these are the 8 or 9 fields are there, main broad areas are there, where this technology, this AR and the VR technology is finding its applications. We find that in educational sectors, here in the VR has already entered for training purposes. Students can get a training, okay, and this includes the laboratory training also. So they can do a lot of laboratory experimentations with the help of this AR and the VR technology. And then flight purposes, flight simulation purposes, to feel the experience of a pilot's. Okay, so one can have a AR and the VR systems through which a person can have a feel of a pilot. And then we discussed that it has a tremendous applications in the medical field, AR, VR technology. So one of the cases that the AR and the VR technology can be used, that is for the treatment of the patients, okay, for the physical improvement of a person's, or the mental improvement of the person's, or to understand the problem of the person's. So this AR and the VR technology is used. Even I also mentioned that this virtual reality concept, okay, so this concept is also used for after what I say that after means operations, okay, after the medical operations, how a patient should get should be treated like, okay. So how the caregivers will provide the necessary support to the patients at home. So it's required, sometimes it requires a special kind of training, and the doctors are now providing this virtual reality, means taking the help of this virtual reality, okay, concept for development of the software tools, and this is provided to the patient party, okay, or the caregivers. And if they go through this technology, if they go through, then they will be understand that at what situations, what type of action has to be taken. Okay, so there is no need that it should be taught by the nurses or the doctors to the patient party. So the patient party can have a software interface through which the patient party, they themselves come to know that how a patient should be treated. So this is the new technology, new applications of this AR and the VR technology. Already I mentioned that there are 20 clinical sectors are there where this AR and the VR systems, they are finding its interest, and a lot of what I say that a lot of market is there. Medical treatment purposes, even when the doctor is doing certain is doing some sort of surgery, okay, so at that time the doctor can help the concept of virtual reality concept, okay, for doing the proper treatment or for doing proper surgery of the patients. So for that purposes also it can be used. And already I mentioned that this is the situations where a patient can interface with the model, okay, AR VR model, okay, And if the patient does not want to share his or her problems with the real human, then artificially one can take, the patient can talk with an artificial caregivers, okay, and the artificial persons may also understand the situations of the real persons, and accordingly the advice may be provided. And I will play this video also. I have a video on this type of systems, and this is completely based upon some movements of the person. So on the left hand side, this is the patient. He is a patient, and the body movements, then the eye movements, then the lip movements, then the head movements, everything can be measured. And for that purposes, there must be a sensor systems must be present over there. Okay. So generally what happens, where the patient is located at that locations, generally a camera unit is provided, and this camera may be a Kinect based camera. Is a very special type of 3D camera systems is there. So which can be placed in front of the persons, and whenever the person is talking, okay, then the movement of the persons, the different movements of the persons, head movements and the shoulder movements, okay, the eye movement, everything is measured. And from there, the physical state and the mental state of the patients can be understood by the ear and the VR systems, and accordingly the remedial measure can be taken. It has been already found that this ear and the VR concept can be used for the pain destruction purposes. Okay, so sometimes it is found that in case of burn injury, treatment of the burn injury, so it's a very critical one, and it's a very painful process for the patient. So during this time, if a person is engaged with the ear and the VR sets, okay, and if the persons spend most of the time with this head-mounted display unit, then at least it has been found that 40% of the pain is get relief. Like, okay, so pain is there, but the person who is the patient, so he or she forgets about the pain part, and it has been found that 40% to 44% relief is automatically the persons can feel when the person is working with the ear and the VR systems. VR systems is also used for agricultural purposes. Okay, and say for example, this is a rural environment. Okay, this one is a real environment, and on this real environment, you can put some sort of virtual objects. Okay, and you can this is basically a robotic systems. This is a small robotic systems. So this robot may be asked to reach to these virtual objects, and you can see that how the robot is moving to these virtual objects. Or even you can teach this particular robotic systems to reach to these virtual objects. This may be the fruits, but these are all virtual. So whenever it is moving towards the virtual object, you can record the path that the robot is following. So you can record the path. And in this way, you can teach a robot, robotics type of systems, that how the robot should actually behave if it is used for picking up the fruits in a real environment. Here also you can see that on the right hand side, okay, so on the right hand side, this is completely a virtual objects. This is not a real objects. Everything is virtual on the right hand side. So a robot system is there, and the virtual tree is there, and there is a container. Okay, so how the robot will pick up the objects from the trees, the fruits from the trees, and then where the robot will place. So you can write a code, write a program, and this may be the teaching method. So we can teach the subjects of robotics, or we can teach the subjects of robot programming to the students by this virtual model. So the students can do this exercise for a number of times, number of periods, endless number of times you can do this exercise, and which may not be possible in case of a real system. So if you have a real robotic systems, students may get an opportunity to work with the robotic systems for maybe for a very short duration of time period. So and sometimes if the students make some sort of wrong programming, okay, then the robot may hit with some obstacles, and it will damage. So that's why in most of the cases we cannot afford a robotic systems to be handled by a students. So this is one of the important area of this augmented reality or the virtual reality, is that the students can be exposed to a virtual type of robotic systems, and he can play for a number of times, endless time he can play with. Then we find that this AR and the VR systems is completely, it is means nowadays it is used in the industry 4.0. So in the case of we have 3 industries: industry 1, industry 1.0, industry 2.0, and industry 3.0. And now whatever the industry we have, that industry is known as industry 4.0. So the industry 4.0, it indicates the transformations and the rise of the new industrial digital technology, which makes the gatherings and analyzing the data across the various machines possible, resulting in the faster, flexible, and more efficient process. So in case of an industry 4.0, the main objective is to understand the systems, and for that purposes, the systems, the total systems captured lot of information, lot of data, and then these informations of the data are processed, and from there generally the high-tech technologies are built up, high-tech decisions, okay, intelligent decisions are coming up. So these revolutions has increased the productivity and fostered the industrial growth that changes the competitiveness of the companies and the regions. So one of the greatest promises, and at the same time one of the main focus areas of the industry 4.0, is to bringing the digital systems or the cyber systems or the virtual systems or the physical systems. That means the digital, cyber, then virtual, and the physical world, and hence the focus is on the cyber physical system. So most of us, we heard about this cyber physical systems nowadays, and the industry 4.0 is practically this based upon the concept of these cyber physical systems. So the product designs, then the virtual training simulations, okay, and focus on the important assets, finding out the assets, then the scenarios, then the security aspects. These are all taken care by the AR and the VR systems. So we can find this AR and the VR system is one of the key important component of industry 4.0. So these are the industry. I will show some videos where I will play this, how this augmented reality and the virtual reality is helping the industry people to understand the machines or the systems, to take some maintenance kind of work, repair kind of work, even for the installation of the machines, how the installation engineers are taking the help of this AR and the VR concept. So it has noted over here that what are the areas in industry 4.0 where this AR and the VR technology can be employed. So with this idea, I'm just like, say for example, nowadays you can see that this is an environment, okay, and this environment may be a real or maybe a virtual environment. So if I consider a real environment, the question is that if I am interested to add a virtual object over here, then I can also do, okay. And also at the same time, if you say for example somebody is sitting on a chair, okay, and if some music is going on, then how the person will feel about this music part. With this little bit of introductions, okay, I go into the play of some of the video systems, okay? And this is the we can say that on the right hand side we find some of our research activities that we do in our School of Mechatronics and Robotics area. So whatever you are finding over here, Okay, so these are the our own developments. Okay, so we prefer to work in the hardware area rather than working on the software area, and we work in the area of robotics, mechatronics, industrial automation, CAD/CAM, image processing, and then also we include the rural technology also. So our main focus is on the development of product or development of a process or the improvement of the process. So now I will play with some of the videos. Can you see this video? Hello?
Yes, Professor. Yes, it is visible.
Is visible?
Yes, Professor. It is visible.
Okay. Okay. So I'm just I will go through few videos right now, okay, to see that what this technology AR and the VR technology. And now you can see that this AR and the VR technology, how the people are using these concepts. This is basically an applications of industrial assembly operations. Okay, and these are very critical components. This is a like you can say that this may be a piston cylinder arrangement with some mechanisms. So this may be the part of mechanical engineering, and the person is getting some kind of training that how this particular systems can be assembled. Not only the assembly, he can also do the disassembly also. Okay, so this is a training method, and you can see that the person is here. There is a person, and he is doing some kind of hand movements. So there are both hands are there, right and the left hand is there, and this one hand is connected. Say for example, the right hand is connected with a marker. Maybe the red one is the marker, and the left hand is connected with another marker. Okay, so there are markers are there, and whenever the person is moving his hand, you can see that he is doing the movement in the space only, in the air medium only. He is not doing anything. Actually, he is not picking up anything. He is just having a kind of motions only. Now, this motion is basically distract under the camera unit. So there is a camera. Okay, top of it there is a camera unit. So whenever the person is moving either the left and the right hand, the camera can understand that which hand is under movement, and accordingly these hand movements like picking up something and then placing it. So this has a what I say that it has a rules like. Okay, so whenever these rules is followed, the systems can understand that what is the intention of the persons, and accordingly in a soft form, in the graphics form, a particular object is picked up and it is placed at a particular location. So this may be that assembly process, or this may be a disassembly process. So sometimes in case of sometimes in case what happens whenever the systems is very complicated and it requires a lot of training for the assembly purpose. You can see that the person is now getting some kind of training that how the components can be assembled. So he's putting one by one components, okay, picking up and then placing it at a particular locations. So if we can do this, if we can practice this one, then when the person will go to the real environment for the real assembly operations, then the chances of making any mistake will be far reduced. Okay, so that's why for a complicated kind of systems, it is always necessary for complicated type of designs, assembly purposes. It is necessary that a person should do or should take the help of AR and the VR technology, okay, for learning the concept of assembly process or disassembly process. So on the right hand side also, you can see at the top also, there are two hands are there, two hands movements are taking place, and the hand movement is connected with the markers movements. So picking up the marker, placing of the marker, and the marker is connected with the job. So you can see that the person is practically speaking, he can learn very well the concept of mechanical assembly and disassembly process. Audio is also very hello. You can hear the audio also. So you can see that basically this is a mechanical systems, and this mechanical system is known as a robotic systems. And this is it is a virtual model, virtual robot model. Okay, and this virtual model is basically, it is connected with the marker. So the white page. So this white page is acting as a marker units, and the marker is attached, or the robotic system is attached with this particular marker. So wherever the marker is moving, you can see that this particular robotic, the CAD model of the robot is able to move. And if you wants to, this robot can have a movement, like it looks like a human type of hand systems. So where we can move our hands. Okay. So similarly here also the robot can move its arms. And these arm movements also you can do it. You can control the movements of the arms with the help of your graphic systems. So on a software side, okay, you can find that there are certain knobs are there. Joint 1, joint 2, joint 3, joint 4, joint 5, and joint 6. So there are 6 joints are there located in this manipulator unit. So whenever I move the joint 1, okay, so this pointer, if I move the pointer of the joint 1, then the joint 1 will move. Either it will move on the right hand side or the clockwise directions, or it will move in the anti-clockwise directions on the left hand side direction. So in this way, you can control manually, you can control the movements of each and every joint of these robotic systems. But the fact is that this is known as augmented reality, where we can say that the environment is augmented here. So the environment is a realistic environment where your CAD model is basically, it is augmented. Okay. Marker may be placed at any places. So accordingly, the robotic structures will also move. So this virtual model, you can move the virtual model. It's a conveyor belt where there are 2 objects are there which is moving on the conveyor belt. And this is the virtual model. It's not a realistic model, it's a virtual model. And this is the virtual assembly. Complete systems. The robot along with some conveyor belt, the material, handling devices. Okay, so they are all placed as a single unit. And you can see that the movement of the robot is simulated. And you can see the movement of the robot on the virtual environment.
Digitalization is one of the most important driving forces for technological trends and new developments. The networking of machines and systems, as well as gathering information on basic and status data of devices, forms the basis for that. The added value this data provides is demonstrated in Phoenix Contact's in-house tool shop. Thanks to the comprehensive networking of all machines and tools in production, setup times of injection molding systems can be reduced significantly. Every workspace offers access to tool data and databases with animations and 3D models on every tool. In addition, toolmakers can also use augmented reality systems that facilitate processes and reduce the error rate. That's how the complex injection molding tools can be classified immediately.
So here you can see that this is the background is the real objects. Okay, so the background, what you are finding over here, so this is the real objects. This is an industrial environment. But when this, when the software side, okay, the graphics sides, this is imposed on a real objects. Now it becomes as a augmented reality. So some information. So here you can see that the information in the form of a graphics is augmented on the real environment, and how these augmented reality systems will work. And here you can see not only that, whatever the information is coming, this information may be a static type of informations. Okay, say for example, he wants to see that what is the machines, what is the name of this particular machines. So somebody is working on a industry. Okay, industry means passes, and then if somebody wants to know that what is the name of this particular machines, then within a click, okay, it is possible to know that what is the exact name of that particular machines. Even say for example, somebody wants to know that what is the particular temperature, what is the temperature of that particular machine at that particular instant of time. So that also it is possible to know, and within a click only, the temperature of this particular machines, okay, at that particular instant of time, it will be visible on the screen. So on a computer monitors, or maybe on the mobile, okay, on the mobile screen. So along with the background of the objects, that the exact temperatures of that particular machines at that particular instant, it will also appear. And this may be a continuous process. So if the temperature is continuously changing at that particular site, then automatically you will find that the temperature is continuously, it is increasing, either increasing or it is decreasing. So that means it is not at all, the graphics part is not at all, it is not only a graphics, but you can say that you are getting the real informations, okay, in the form of a graphics, you are getting a real informations of the environment. So that is the beauty of this virtual reality.
Sprue runners, heating and cooling circuits, as well as the optimum tool temperature are indicated, precisely where they are located. The facility management in Bad Pyrmont also uses AR technology today. The required data is provided by Analytics, the Phoenix Contact building management system. Thanks to the intelligent networking.
So you can see that a lot of information is coming on the machine side. Okay, and this is the augmented reality where we can see that what is the temperature of the machine. So it is showing the temperatures. Maybe some other information is showing that is it may be okay, like 360% is giving, okay, and the kilowatt rating of the particular machines, that is also showing, and then other maybe that kilowatt hour, okay, the machine rating is also you are finding over here. So a lot of information you can get at the same time, not only from the machine, not only the look of the machines, the actual look of the machines, but also you are getting a lot of information about these particular machines.
Of the entire building technology, every user has access to the right information at the right time. External maintenance personnel is led independently and informed about everything that is important in the event of a maintenance work. Controlled safety instructions are given directly on the spot, immediately before use. With the high level of data depth, Analytics creates transparency. Augmented reality technology makes it possible to experience this transparency. If you are also interested in experiencing augmented reality with regard to Industry 4.0 and building technology, come and visit us at one of our sites. Together with you, we develop your own digitalization strategy.
So for this one,
our hand tracking technique uses only a webcam and a color glove made of a stretchy lycra or swimsuit material. We can track the 3D pose and configuration of the hand. Our system is low latency and can track the fast 3D motion of this sequence.
So you can see here in this case, what happens, a person is wearing a data gloves, and you can see that the color of the data gloves, okay, which is a multicolored objects, like, okay, to identify the movements of each and every fingers, like. Otherwise, sometimes it may happen that the locations of one finger is covered by the locations of the another fingers. So to identify the locations of each and every 5 fingers, like, okay, and to accurately track the motion of the human hand, you can see that the movement of the human hand is plotted in the form of a CAD model. So there is a CAD models, and this CAD model, the CAD hand, will follow the actual hand. So this is an examples that how the movement of the real objects is captured. The movement of the real object is captured, and then it is transferred into the CAD model. And this CAD models is a dynamic model. Let us see this.
Here we show a prototype of a desktop virtual reality application. The user can pick up blocks.
So here you can see that the person is getting some kind of training that how the different parts or different components should be assembled, one above the another. So what is the sequence of operations? That also you can learn it with this help of this here in the VR technology.
Blocks, move them, rotate them, and stack them, all in 3D. Here we demonstrate a more complicated example using both hands, where we explore and virtually disassemble the components of a disc brake.
So it's a disassembly process. Okay. So in the case of disassembly of a mechanical systems, you can use your both hands, and the movement, the actual movements of the human, it will be coupled with the CAD models. Okay. So realistic, it will be have a realistic CAD model. So each and every components of the CAD models, you can take it out, or you can place it at the proper locations. And through this particular kind of training systems, it is possible for the engineers, okay, or for the assembly people to know the complicated kind of systems or get training of a complicated type of system, so that whenever the actual systems will come, okay, for assembly purposes, so they will not make any mistake. So the actual assembly process is going on, tightening process is going on, but at the same time, the augmented reality is helping the persons to understand that what is the torque that has been applied for screwing purposes or for the unscrewing purposes. You can see here this lighting systems. You can see that the lighting systems will help the persons to understand that where this particular component will be assembled. So these are the features of here in the VR technology. Say for example, nothing, no object, no components is placed over there and that particular bin, and somebody is picking up some components by wrongly from that. So immediately the colored means the light systems or the audio systems will give a warning that you have placed your hand in the wrong bin. Okay. So immediately the person will pick up the objects from the right one. So sometimes you can see also this here the system is showing. Here practically the system is showing that where the screws are located. Okay, you picked up the screw, but you don't know that where the screws should be fitted. So this augmented reality is helping the assembly persons to locate a particular screw, desired screw at a particular locations. So the operation is realistic. Okay, the operation is going on in a realistic way, but at the same time, that augmented reality is helping the persons to understand the total process. And even if it is giving some sort of what I say that some sort of clues that which action has to be performed after which actions. So if I have completed some actions, okay, during the assembly process, so what next? The question is what next? So the virtual reality is helping the persons to carry out a sequence of operations. So an assembly people, he or she does not have to remember all these operations. Okay, the virtual reality will guide the persons for the different steps that needs to be followed for doing these assembly operations.
Hi, I'm Ellie. Thanks for coming in today. I was created to talk to people in a safe and secure environment. I'm not a therapist, but I'm here to learn about people and would love to learn about you. I'll ask a few questions to get us started. And please feel free to tell me anything. Your answers are totally confidential. Are you okay with this?
Yes.
So, how are you doing today?
So you can see that there are two objects are there. One is the virtual objects, another is the real objects. So the real persons is there and the virtual persons is also present. Okay.
I'm doing well.
That's good. Where are you from originally?
I'm from Los Angeles.
You can see at the bottom, the person's skeleton structure is visible. Okay. And this is basically if the person is standing, then the movement of the total person's movement, it is captured by a Kinect camera unit. So the Kinect camera will capture, after capturing the objects or the image of the persons, then it will make the skeleton from the images. Okay, so you can see that the green color one is basically the skeleton. So there are two hands are there, two legs are there, the head is there at separate units, so that the systems can understand that whether the hand movement is taking place or the leg movement is taking place or the head movements is taking place. So for that purposes, this what I say that the Kinect based camera unit is used for capturing the motion of the person.
Oh, I'm from LA myself. When was the last time you felt really happy?
When was the last time? I don't know. Yeah, I'm not someone who's really like, I don't have any real highs. I feel like I'm a level person. It's just happy. I guess to answer your question, probably a couple months ago.
So we can find here that the movement of the head. Okay, so one is virtual cube is placed. Okay, so this virtual cube is attached with the movement of the head to understand that how frequently the head movement is taking place. And also you can see that the smile level, you can see that the smile level is very poor for this person. Okay, and then the speaking, the way the person is speaking, so what is the amount of mouth opening is taking place. So these are all indications about the mental state of the persons. So now it is possible, means through this augmented reality, you can see that on the real objects, a virtual object is placed. So it is an augmented reality case. So through this augmented reality, it is possible to find out the mental state of the person, any person's life.
I noticed you were hesitant on that one. Would you say you are generally a happy person?
I'm generally happy. It's just lately there are things just keeping me down.
Can you tell me more about that? When was the last time you felt really happy?
So you can see that there are two persons here.
But I try to stay happy. I'd rather be happy. My kids keep me going.
What advice would you have given yourself 10 or 20 years ago?
To not believe, to not be so gullible. To not be so gullible. I've been told recently that I have a tendency to believe people too readily without them having to prove anything, and so as a result, recently I've gotten myself in a lot of trouble. And so I think that looking back, if I could have, I would tell myself to not believe, to not be so stupid, and to think, and just to not be so gullible.
So here in this case, we can see that there were two persons was there, okay, and two different mental state, okay, and it is possible to find out, or it is possible to identify the mental state of the persons. So here the caregivers or the persons who is basically listening the issues or the problems, okay, so that is a virtual objects, okay. So that means that we are sharing our experience, or we are sharing our informations, okay, with the virtual objects, not with the real objects. So a person can freely talk regarding the mental state or the mental state of a person's, okay, freely, if the object is a virtual, the listener is a virtual objects. So this is very good applications of this virtual reality concept or augmented reality concepts, and we can see that how people are thinking, means how the people are thinking for applications of this AR in the beer in the medical field and the industrial field as well. And let me.
Hello and welcome to this Unity package that is called. Then you have the other degree in order to grab things. So
I'm not showing this one. That will be better, I think. This is the work in our laboratory. So the student is trying to use this augmented reality and the virtual reality, and for the tracking of the hand movements. So what happens here? The person will move the hand in space, and we will see that the movement, the real movement of the hand, it can be tracked with the virtual objects. So first of all, this process is known as a training process. So the training is going on, okay. So the virtual objects and the real objects should know each other's, the positions and the orientations of the virtual object and the real object should match with each other's. So initial part was a kind of registration process, and after the registration process is over, now this virtual object is basically stuck with the real object. So if the real object is moved, if the real object is having some sort of movements, then the virtual object is also getting the same motions. So the virtual object can track the the movement of the real objects. Okay, so with this, I tried to provide you the current status of AR in the VR technology, and this should also be known to the participants. Okay, because in this FDP, maybe it may not be possible to cover everything with the hands-on type of sessions. Okay, but at least the participants should have an understanding that what is the level of this AR and the VR technology nowadays. So, and then accordingly they have to prepare themselves. Okay, so with this little bit of introductions about this AR and the VR systems, now I request Shaptak Bhattacharya, my student, okay, to start with this Unity 3D. Okay, so how to use this Unity 3D for virtual objects or for making the AR and the VR systems. Then the different types of VR-based app development process, and then control the virtual objects with the help of the real objects, how it is possible. Okay, so I request Shaptak to start with.
Thank you, sir, and good afternoon, everyone.
Yeah, good afternoon, sir.
Let me share my screen. My screen is visible?
Yes, sir, it's visible.
Okay. So just a quick recap what we did earlier in the first day. So in the first day, we discussed how to open a Vuforia developer portal, as well as how to register and log in the Vuforia portal. Next, how to create a license in Vuforia. So how to create a license in Vuforia, and we have to copy and paste the license. So in the license manager, we can create a license, and once the license creation part is complete, and we have stored the license in Notepad in the similar folder where we want to store all the necessary files, then we will further move to the target manager. So we also have seen how to create a database in target manager and how to upload a specific marker image in Vuforia, and what does augmentability rating stands for. Once the target has been uploaded, then the database needs to be downloaded and stored in the computer in the same place where the license has been kept. And then we will open Unity to create a new project. So when we want to create an Android app or PCBase.exe application, so we will select the corresponding part. To create an Android app, we will click on Android, and in the player settings, we will go in the XR settings. And in the XR settings, we have to check the Vuforia augmented reality checkbox to use the Vuforia plugin in Unity. And then we will click on, and after developing the scene over here, we will click on this build. So if we click on build, then an Android app will be created. We can take it in our phone and we can run the app. And next, we have seen that how to create the image target in Vue4ya, how to upload the databases. So first we have to import the AR camera asset. And then we will add license and the database in Vue4ya. So once the license and database has been added, there will be 4 checkbox options in the Vue4ya configuration file. We have to uncheck them all, and only we have to check the first option and activate it. Now, once the license has been given, then we have to create an image target. Now, why we are creating image target? Because this image target, there will be a real-time image target in the real world. So a virtual image target also needs to be created in Vue4ya, and all the virtual models will be a child to the image target. In the image target, we have to select the database which has been downloaded from Vue4ya. We have to orient the camera so that it can properly view the image target. Next, we will create a game object. We can add some textures to the game object to make it more beautiful or realistic or for aesthetic purposes. And then if we retest it, we will see that the game object has been attached. So not only this, we can also add some animation to the game object. To do that, we will need the use of scripts. So we will attach a script to the game object. We will open it in the MonoDevelop, or if Microsoft Visual Studio has been installed, then it will open in the Microsoft Visual Studio. So in the script, we have to write the necessary code for animation. This is the command for animation. So once the code is created, if we test, we will see the game object, how the game object is animated, how it is moving upside down. Now we can, we have seen how to create game objects, how to animate them. We can also use videos as a game object. The procedure is same, only in the place of the cube, we will use a video. So this we are importing a new object known as plane, where the video will be uploaded or added. And this plane object needs to be made a child of this image target. So I have placed the plane object perpendicular to the image target. And I will add the video to this plane object. So we will click on add component video player, and in the video player we will select the video that has already been uploaded in the asset. So I have renamed the plane object as video plane and uploaded the video or added the video to the video plane, so that when in real time the drawing copy image or the target image is detected, the video starts playing. Now this was what we discussed in the last class. So today I will be showing you that how to manipulate AR objects through virtual buttons, how to manipulate any game object with the help of virtual buttons. So let me show you the video. So in this video, we will test the AR application based on robotics in Unity 3D. So in this video, when the computer camera or the mobile phone camera detects the drawing copy image, it superimposes an AR virtual object, which is a robot. And we also have some sliders and some virtual buttons over here, which we will operate, and we will see how the robot moves over here. So whenever this marker is detected, then Unity superimposes this virtual robot in its screen. And the interesting part is this robot can be manipulated in real time. That means we can change the joint angles of this robotic manipulator. It is having 3 angles. First one for base rotation, second one for this elbow rotation. The computer sound is audible. The video sound is audible.
Yes, sir. Yes, sir. It's audible.
And third one for wrist rotation. So theta 1 corresponds to base. So this is how, if we change the theta 1 changes the base rotation, and then the theta 2 is the elbow. We are getting sort of this, and theta 3 for the front portion of the wrist option. So here beside the slider, the joint angle is also shown over here in degrees. So by changing these 3 angles, we can move the robot in any of the part of its workspace actually. So yeah. Now another interesting feature of this application is we can save positions and we can make the robot to reach all those positions in a sequential manner, like point-to-point planning or the path planning. So for that one, the inverse kinematics of the robot has been programmed in C# in Unity. And now if we give the specific positions, input positions in the form of XYZ, where we can just click and save position. So the robot is already here, so we click on save position and the robot saves its first position. Then we move the robot a little bit. Let me say this is the second save position. Then let me just change the base rotation. Maybe this is the third position. Then again this is the fourth one, and then again this is the fifth one. So if I save these 5 positions. And so after that, we have to enter time over here. Time window maybe of 3 seconds. So each and every step will be iterated 3 seconds. So then if we click on go to save, so we'll see the robot automatically starts following all those positions. So it completes its task. So we can clear the positions by just clicking this clear position. So this is what we, this is how we can interact with an AR object in real time. But how this is done, I will show you. Now here, like this previous one, we have a VR model of the robot, CAD model of the robot. So you can design the CAD in any CAD software like AutoCAD or Autodesk or Fusion 360, Autodesk or SolidWorks, any CAD software of your choice, and you can import that CAD model into Unity 3D. So in file, you can import those CAD models under assets. So you have to click on import new asset and you can add the CAD model. So once the CAD model has been imported, I also imported the CAD model. Once the CAD model part is imported, so you will see that I have also created the AR camera for using View4IA. Now the other procedures are same. We have to create a image target. Under this image target, the robot, which is the virtual CAD model of the robot, will be a child to the image target. We have to make it its child. So when the robot comes, we will see after successful import, it will be consisting of several things. The first thing is the robot, which is having its lower platform base. So if I click on this lower platform base, it is consisting of this back glass, then bottom disc, lower gear. So each and every component of the robot has been shown over here. So this is the components of the robot. So this will be imported once we import the CAD model. Next, we have to create some event system, then canvas. What is this canvas? Now canvas is where I have placed the virtual model, because if I show you the video, so if I show you the video, so in the video, this is the canvas. So in the canvas, there are 3 sliders and there are virtual buttons. So where we are adding the sliders or virtual buttons, this is known as canvas, where also the joint angles are being displayed. So the canvas needs to be created in Unity 3D. So in canvas, I have created button stop, theta sliders, save, run, position, time, field, move to. So all those things has been created in the canvas. So from where we will find the canvas? So in the game object, there are lots of options like 3D object, and we have 2D object, effects, lights. So if we come to UI, so in UI means user interface. So in UI, there are lots of options like text, image, raw image, button, toggle, slider. So we can import the sliders from this UI section. Then we have canvas over here. So first we will create a canvas. Next, I have used the button stop buttons or sliders over here. So all of those things can be imported from the UI parts. So from this button, the buttons can be created in the canvas. So buttons may be placed in the canvas. And each and every button has its own position and orientation and how the button will look over here. So next, we have to create an event system. So what does this event system mean? Event system basically we are creating because whenever we are interacting with the AR object, so basically we are interacting with the virtual buttons. So for pressing or for interacting with each and every virtual button, an action is taken. So basically that is being done by this event system. So this event system, so which button or when we are pressing one button, what action will be taken, that is basically decided by this event system. So event system acts as an interface between the canvas as well as the other scripts in the system to control the virtual object or the AR object. So this is why we have to create an event system. So we have to create a canvas, we have to create the event system. We have already created the virtual model of the robot. So this canvas and event system all will be the child of the robot, because whatever behavior the robot will undergo, the canvas behavior will undergo the same properties. So that is why we are making its child. Now the next thing is robot control. We have created another event over here, so which is known as robot control. Now this robot control element, if we click on this robot control, we can see from here that it consists of several scripts. So the first one is initialize arm. The next one is theta3 upper arm slider, theta2 lower arm slider, base slider, theta1 not points. So theta1, theta2, theta3, these are basically, these scripts are basically responsible for showing what joint angle the robot is currently, undergoing. So this is basically the task of this theta1, theta2, theta3 script. And base slider, lower arm slider, and knot points, and the upper arm slider. So these basically commands, these are basically responsible for taking action when we are moving the sliders. So whenever we are moving a slider in the canvas through the event system, this particular script is enabled, and by enabling that particular script, the behavior of the AR object is controlled. So in the previous case, we have controlled the behavior of the object, we have controlled the animation of the AR object. In this case, we can control the motion of this AR object through the use of these scripts. So that is why we are using this event system and canvas. Now, if we
Saptak,
yes, sir.
Can you interfere?
Yes,
I have a small robotic system, because most of the cases may be that some of the participants, they do not have any idea about a robotic system. So, so what I feel that if I can show them that what a robot really looks like, then they may find it interesting.
Okay, sir.
So just a minute. Here, can you see this one, participants?
Yes, sir.
Yeah. So this is known as a robotic systems. This systems is known as a robot. Okay. And this robot is a physical. I'm holding a robotic arm. It's okay. Then this is a very small robot, and this is, we can say this is basically a toy. Okay. But we have a higher version of the robots. That means this is basically the model of a KUKA robot made of Germany. And this is a toy. This is basically a toy robot. But here you can see that the bottom of these robot portions, that means this is known as a column of the robots. Okay, so this can rotate. And then this is known as a fast link. This can also rotate. This link can have a movement. Then this is known as a second link. So this can also move. And this is known as a wrist portion, so it can have a rotations. This can have a rotations like this. So pitch motions, the yaw motions, and the roll motions. Okay, they are associated. These three rotational motion is associated at the wrist end. And so sometimes this is a dynamical systems. It's a dynamic systems. And always for doing certain operations, it has to move from one location to another location. So sometimes the robot may move to this location, and then it will go to this particular location, then pick up some object, then it moves, and then it will place it some other locations. Okay, so this type of simple pick and place type of operations can be performed. So if I want to give a training to the students, So either I must have this kind of toy type of robots. I must give it to the students to play, or otherwise I can make this toy, virtual toy. I can make it. Then if I have the facilities like a joint motion, then the students can automatically through the software sites, okay, through the virtual software site, they can also move each and every joints, and they can move the robot end effectors from one location to another locations, so that they can learn that how a robot should be taught, or how the programming of the robots are done. So so that is the utility. Okay, and what the Shoptalk is now trying that, say for example, we do not have the real robots. The students cannot see the real robots, but they want to learn this technology. Okay, so this virtual reality or the augmented reality, how it is helping the students at least to learn the subjects of robotics. Okay, over to Shoptalk.
Thank you, sir. So if we go in this inside the script, so basically what sir was saying, that if we want to learn the motion planning or path planning things, we don't need a real robot. So we can design our own virtual robot, and we can apply the algorithms, and we can see the robot motion, and we can validate whether the algorithm is performing rightly or not. So this that becomes a big help for designing or path planning or navigation planning of a robot. But how we are controlling it? I have just told you that we have several scripts. So let me show you the scripts. So if I click on this initialize ARM script, so this initialize ARM script is in C#. So I'm opening it mono-develop, so inbuilt Unity editor. So this is the initialize ARM script where a class initialize ARM has been created, and we have taken 3 parameters like joint 0, joint 1, joint 2, and then these are vector parameters link 1 and link 2, and this will be the variable theta, and the transformation will be the base rotation. So this is basically the particular script for initialization of the robot. When we are starting, what will be the initial pose of the robot, that is basically governed by this script. Now this one is the base slider script. When we are moving the slider, then this script is basically controlling the base slider script. This script is responsible for controlling the operation of the base slider. Now this is the DH parameter, or the Dynamite Hundenberg parameter script. So DH parameters comes for motion planning of when we want to do the motion planning of robots. Now this script is particularly useful to that, which mentions several parameters or specific parameters which are related to robot. Then there is the kinematic scripts. This is the kinematic scripts. So the kinematic scripts takes the DH parameter script along with it for its operation. So where the kinematic script is required, basically, as I have shown you, that when I have mentioned the robot to move 5 over 5 specific points, now the robot automatically plans its trajectory, how it will move through those 5 specific points. I have not given each and every point for the robot. I have only mentioned some specific points, 5 specific points. The other points the robot already deduces from using this kinematic script. So if we can load the kinematic scripts into a robot, we can also inverse kinematic script, then we can also do the motion planning and path planning operations of the robot. So this is what I'm trying to explain is the role of the scripts. how they are responsible to control the behavior of the robot. And for that particular application, what I have shown you, there are almost there are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 11. So there are 11 scripts which are basically responsible for controlling the behavior of the AR object. Now you can create your own robot, you can use your CAD model, as well as you can create, you can program the kinematics, inverse kinematic scripts or dynamic scripts, and then you can simulate the motions of the robot and can visualize how your robot is performing. So all those before operating on a practical robot, by using the virtual one or the AR one, we can actually validate our algorithms. So this is what is useful, where the technology comes useful of this VR and AR. Now this was all about manipulating AR objects to virtual buttons. Now next I will show you how to interface an accelerometer with Unity 3D for orientation control of VR object. So till now we were discussing how to control the behavior of an AR object with the help of scripts. Now I am going to tell you how we can control the behavior of a virtual object with the help of real world sensors. So we can take the data from the real world sensors and we can control the behavior of the virtual object in Unity. So what I intend to do is, I want to control. So I want to control the heading of this particular virtual object. I have created a sort of game over here. So I want to control the heading of this particular aeroplane with the help of an accelerometer sensor. So in the insert, I am you can see that I am holding the sensor as well as the data acquisition board. I am using Arduino, and the data is being fed to Unity 3D, and based on my hand movement or this accelerometer data, the heading of the aeroplane object is being controlled. Now, where these systems comes into play, one of the applications I can tell you that flight simulators. In pilot training or in space applications, before doing the training in actual aeroplanes, the pilots go through these flight simulator trainings. So in those cases, they sit inside a sort of cockpit, and they wear these 3D glasses or head mounted displays, and they have joysticks and other sensors to for measuring the real world data, and then based on their input, they basically try to practice takeoff, landing, and navigation of the aeroplane. So flight simulators, technology the flight simulators use, this is sort of like this one. So how can we send a sensor data to Unity 3D to control the behavior of a virtual object? So the board I am using over here is Arduino Uno. Now it's a very popular board, data acquisition board. So it's having Atmega 328P microcontroller. So so basically we are using it because it's cost effective, as well as it is having analog in input output and PWM pins. So that is why this board with its support. So this board I will use for data acquisition. That means this board will be responsible to take the sensor data and to send the sensor data to Unity 3D. So there will be a PC or a laptop will be running, or a phone which will be running a Unity 3D. In my case, I'm using a laptop which is running Unity 3D. I have developed a .exe application, an app for this game. So I've connected the Arduino Uno with the computer using USB cable, and the sensor is connected to the Arduino Uno. So when I'm changing the orientation of my hand, so basically based on the sensor input coming from the accelerometer, the Arduino takes the data and sends the data to the computer running Unity 3D through USB port. Unity then takes the sensor data and changes the behavior of the virtual object, that is the aeroplane over here. Now this is what the software of Arduino Uno looks like. So the code in Arduino Uno, the code syntax basically consists of two sections. One is the setup section, one is the loop section. In the setup section, the initialization parameters are written, and in the loop section, the instructions are written which needs to be iterated continuously. So this is what a typical code syntax of Arduino looks like. Now this is the sensor I'm using for this application, this ADXL335. Now ADXL335 accelerometer is an accelerometer module, which is the electromechanical device that measures the acceleration force. So it shows acceleration due to cause of gravity or force. It measures acceleration. Now the ADXL335 gives complete 3-axis acceleration measurement. That means it measures acceleration within the range of plus minus 3g in x-axis, y-axis, and z-axis. Now the output signals of this module are analog voltages that are proportional to the acceleration. So whenever the sensor measures an acceleration, it generates analog voltages in the range of 0 to 5 volt. And this sensor is basically connected with Arduino, with the Arduino analog pin. So whenever the sensor, there is a change in the sensor value, which is reflected in the range between 0 to 5 volt, that value is taken in the Arduino and is sent to Unity 3D. So this is how the ADXL335 module operates. So basically there are a moving plate and fixed plate, and basically during acceleration, due to displacement of the moving plate, the capacitance between the fixed plate and the moving plate changes, and by measuring that capacitance, it senses the acceleration. So acceleration deflects the moving mass and unbalances the differential capacitor, which results in a sensor output voltage amplitude which is proportional to acceleration. So this ADXL335 accelerometer module, it consists of 5 pins. The pins are VCC and ground. So this is for plus 5 volt supply. So, and X out, Y out, and Z out. So these are 3 output pins which are connected to 3 analog outputs to pins of Arduino. So basically using these 3 pins, the sensor sends the analog output voltage proportional to the acceleration. Now we can calculate the angle of inclination of tilt, as I was showing you. The angle of inclination of tilt by using the XYZ values. So this is the formula. So by using these formulas, the rotation or the tilting from minus 180 degree to plus 180 degree is converted into complete 0 to 360 degree rotation. Now this is how the ADXL335 module is connected with Arduino, and I have already told you that VCC is connected to plus 5 volt, ground pin is connected with the ground, and the X, Y, and Z pin connected with the analog pins with Arduino. In the figure, I have connected here with A1, A2, and A3. So these are the analog pins, input pins of Arduino. Now, once the hardware connection is very simple. And once the hardware connection is complete, this is the code. This is the code for calibration. Now, in this case, I have given 3 variables: constant int, that is constant integer. So X input, Y input, and Z input. So 0, 1, and 2. So basically, I have connected the X input and Y output and Z input. That is the 3 pins, X, Y, Z pin of our the sensor with A0, A1 and A2 pin, the analog pins of Arduino Uno. So, and then, so this is basically the minimum and maximum values for each axis measured from calibration. So this is the code after calibration. This is the main code. So I have declared two variables. One is X minimum and the other is X maximum. The X minimum is 266. The X maximum is 399. So what does this signify? The X minimum value, that is, this is the value which is coming for -1G, and the X maximum value, this is the value which is coming for +1G. So that is during X axis for -1 for 0 degree, we will get the value 266 or near about value 266, and for 180 degree rotation we will get a value of 399. So the value ranges from 266 to 399 for 0 to 180 degree rotation, plus or minus. So this is how the Arduino maps the -0 degree to 180 degree rotation or 0 degree to 360 degree complete rotation in terms of these values. So how we can achieve these values, I will show you. Now in the setup portion, I have written serial begin 38,400. Why this is written? That means the Arduino will be communicating with the computer at a baud rate of 38,400. That means our baud rate means bits per second. That means the Arduino will communicate or send or transmit the data at a speed of 38,400 bits per second. Now the next, in the void loop section, I have written X val, Y val, Z val equal to analog read 0, analog read 1, analog read 2, because I have connected the sensor with analog pin 0, analog pin 1 and analog pin 2. So this command analog read is basically used for data acquisition from the sensor. So the data which are read from the sensor is stored in the X val, Y val and Z val variable. Now next, these variables are basically scaled into to milli GS. So basically whatever value we are getting, it is scaled into milli GS. So that means +1G is 1000, -1G is -1000. So basically what value we are getting, we will convert in between -1000 to +1000. That means -1G. And then after the scaling, we are printing it. So this is basically the Arduino program for now this is the Arduino program for accelerometer calibration. So why we need calibration? Because before actually loading this program, before actually loading the accelerometer interfacing program, we have to calibrate the sensor. So what does this calibration mean? That means, as I have just told you, that for 0 degree, what will be the value, and 180 degree rotation, what will be the value for G, what value is coming. So those values needs to be fed to Arduino in order to understand what is the range between the values for 0 to 180 degree rotation or 180 degree to 360 degree rotation. So this is basically to understand the range between that. So that is why we need this program. Now, this is the program for ADXL335 calibration. So here there are three variables, X input, Y input, and Z input equal to 0, 1, 2. Because we have connected the sensor to the Arduino at analog pin 0, analog pin 1, and analog pin 2. Next, int X raw minimum, int X raw maximum. I have selected both of these values as 512. Why? Because these are the initial values. Then when I will be performing the calibration, I will check what the value is coming for -180 degree and what the value is coming for +180 degree. So I will check. Before checking the values of X axis, Y axis and Z axis, the minimum and maximum values are initialized at 512. If we don't initialize, Arduino will take some garbage values. That is why we are initializing it at 512. Now, once that part is done, then serial begin 30,400. That is the baud rate. Now then there is, in the loop section I have written character start byte is 0. If serial available is greater than 0, then start byte equal to serial lead, serial print, begin calibration received. That means if so in this section what we are doing, we are checking whether Arduino is sending any value to the computer or not. So in this case basically we are checking if the Arduino is ready for communication or not. If we are writing start byte equal to 1, then int x raw is read axis x input. So basically what we are doing over here, during calibration we have to see what values are coming for -1g and +1g, that is -180° and +180° rotation in x-axis, y-axis and z-axis. So for each axis we need to calibrate. So during calibration we have to first place the sensor at -180°. We will take the value, then we will rotate it and we will take the value for +180°. So this is how for each and every axis we will be rotating. Now when we are doing it, how the computer will understand that we have rotated and we have placed it at 180°, at which instant we need the value. So that is why we have done a trick over here. So when I will press 1, then only the value will be taken and printed. That means when I'm pressing 1, so when I will be placing the sensor at -1g at x-axis, y-axis or z-axis, so then I will press 1 and the value will be taken. So this is how we will go on calibrating, which is basically done by this auto calibrate function. So I'm not going much deeper into this auto calibrate function, but let me show you how this calibration is performed. Now I have connected the Arduino with the computer. I'm not sending the data now to the Unity because the calibration is now going on. Once the calibration is complete, we have to take those values which has been obtained from calibration, and we have to place those values in the main program for accelerometer interfacing, and then only we will start Unity. We will be start sending values to Unity. But now we are basically, we have connected the sensor with the Arduino, and we have connected the Arduino with the computer with a USB cable, and basically I will be starting the serial monitor of Arduino to see at what are the values are coming for each and every sensor position. So I'm connecting it. So once the sensor is connected, I will click on tools in Arduino and I will click on serial monitor. What is serial monitor? Serial monitor shows the data which is coming from the corresponding port. That means what are the data is coming from the sensor to Arduino. It will basically display those data. So first I will select the communication port, at which port Arduino is connected and what board I'm using. I'm using Arduino Uno over here. So first I have to select both of these things. So here it shows the Arduino is connected with the computer through COM port 4. We need to know the COM port number. So I will upload the code to the Arduino and I will open the serial monitor. So I have opened the serial monitor. So it is not showing anything. Why it is not showing anything? Because I have not pressed 0 or 1 or anything. So I have pressed 1. I have written 1 and I will click on send. Whenever I click on send, it tells us begin calibration, receive 1, calibrate raw ranges, X ranges between 331 to 512, Y ranges between 269 to 512, and Z ranges between 316 to 512. So I can see from here that the values for -1g and -1g for x-axis y-axis and z-axis is 331, 269, 316. So for the first time I'm getting this value, I will send 1 continuously and I will be taking the values continuously to see what are the values are coming from for each and every x-axis, y-axis and z-axis. What are the minimum values? What are the maximum values? So I will, in the position I am holding, I will rotate it 180 degree. So I rotate it. So you can see in the breadboard the sensor is placed, and I will send 1 again. Now in this case you can see that which one changed. This was 269, the y was 269, and when I changed the orientation, the y now became 391. So this is for 0g. So y for 180 degree rotation, I am getting 391 for y. So this is how for each and every position. So that means I have given a shift of 180 degree in y axis. If I completely shift another time, so I will be getting plus 1g. So this is how, if I change, and I will continuously be changing the orientations in x-axis, y-axis and z-axis, and I will be recording those values, and for each and every value what I have got for minus 1g and plus 1g, I will make an average to find out what is the minimum value for x minimum and x-axis, and x maximum for x-axis, y minimum, y maximum, z minimum and z maximum. This calibration part needs to be done for several times. So you can see from here I have changed the orientation in z-axis and I am trying to take the values. This step will go on continuously. So I have seen over here that the x minimum value I have got for minus 1g is 266, and for plus 1g in x-axis is 399. Y minimum value for minus 1g is 266, plus 1g came as 399, and z minimum value for minus 1g is 268. Z maximum came as 403 plus 1g. So these 6 values we need to find out from calibration. And once the calibration part is done, then we can go into the main program. So this is the main program. Now I will upload the main program to Arduino. So when I upload the main program to Arduino, now it is showing those values in G, corresponding G, the X, Y, X axis, Y axis. So I am changing the orientations. You can change, see in the inside video, I am changing the orientations and I am getting those values. For different orientations, I am getting different values. That means the X axis, Y axis and Z axis values, Z values for acceleration I am getting from here. Now it is time to find out the orientation from this corresponding X axis, Y axis and Z axis acceleration, because these you can see from here, these are here in terms of acceleration, and I have shown you the formula by using which we convert these values from acceleration to corresponding orientation angles, and that program, that code will be written in Unity 3D, in a Unity 3D script. So the next thing comes as Unity 3D game environment configuration. So in the game environment, what we will do, we will import the CAD model of the aeroplane. So I'm creating a new project and I will click on file and then build. So build settings. Then if I want to run it in PC, then want to create a .exe application, then I will select the corresponding platform as PC. If I want to create an Android app, I will select the Android. So I have given or saved the name of the scene as VR sensor demo. Now next what I will do is I will import the environment. So environment means where so this is an inbuilt asset of Unity. So we just need to import it. This is already given in Unity. We can import it. So environment means how I want the environment to look like, how I want to make it. So I'm importing the environment. So these are all those files which we need to import from environment. So once the environment is imported, we will have lots of textures, terrains in under the assets column. You can see from here. Now next I will import terrain. So terrain means where so how the terrain will or the ground will look like. So I have imported a terrain over here. I will add texture to the terrain to make it a little bit more realistic. So we can have different types of terrains. So the terrain I have created over here is just now a white plane. I will decorate the terrain to make it more realistic. But now I will be importing the CAD model of the aeroplane, which I have downloaded from Unity. So I'm importing the CAD model of the aeroplane. So these are the different CAD models of the aeroplane available, what I have downloaded from Unity. I'm just importing them in Unity. So once the CAD model is downloaded, now I want to control the behavior of the aeroplane object in Unity through the help of scripts. That is why I am creating a new folder as scripts where I will place the scripts. So there are three scripts over here. One is I will show you the details of the scripts. The scripts will be responsible to take the value from the sensor which is coming through the Arduino and to calculate the orientation from the acceleration values and to control the behavior of the aeroplane. So this is the CAD model of the aeroplane, now it is looking. Now once the aeroplane is loaded, I will now decorate the terrain. so that it looks like a little bit rocky or green, covered with plants. So from the terrain settings now I can make the plane a little uneven. So in the terrain settings there are brushes. In this brushes option we can create mountains. So you can just click and drag it and mountains will automatically be created. This is how the terrain looks like. This is where the plane is. Now I will place the plane at a position which can be better viewed with the camera or the main camera. So I am not using the AR camera over here because this is a VR application. I am using the main camera. So I have to check whether that aeroplane is visible in the camera preview or not. If not, I will make some adjustment in the position of the plane to make it visible. So I'm changing the position of the main camera. So now how it looks in the view from the main camera. This is how the aeroplane looks like. Now once this part is complete, now we will go to the scripts. So there are 3 scripts. One is plane animator, one is propeller animation, and third is scoreboard for the game. So I will open the plane animator script. So if I open the plane animator script, we can see from here how the script looks like. So this is in C# language. So there are 3 angles, X angle, Y angle, and Z angle. So basically I have written ADXL 335 protocol, so it will understand how to convert the acceleration from value of in terms of +1g to -1g. And then here is one variable, serial port manager. So serial port manager handles all the communication between the Arduino and the Unity. And then there is another variable comport equal to COM4. So you can remember that the Arduino was connected with the computer with COM4. So we have to specify over here. So whatever comport the Arduino is connected, we have to specify that comport in this place. So I've given the comport as COM4. The baud rate should be whatever the Arduino is using the baud rate. So in Arduino, the baud rate has been set as 38,400. So in Unity also, we will select it as 38,400. So once the comport and baud rate is created, then here we are basically what we are doing, we are actually calculating the orientation in x-axis, y-axis, and z-axis from whatever values we are getting in Arduino. So this is the line which is using the formula to calculate the orientation from plus 1g to minus 1g value. So the acceleration is being converted to orientation in this part. So once this part is done, then what we will do? We will now go to the build settings because we want to develop an app. I want to create an .exe application app. So when I will be clicking the icon, the app will open. So I have selected PC and I have clicked on build, and I will give a name to the application. And the type will be .exe or exe. So it is now creating the application. Now this is the application which has been created. Now we can see if I change the orientation and position, the heading, the orientation of the aeroplane also changes. And you can see the propeller that is rotating. So the rotation of the propeller is being controlled by the propeller animation script. So this is how we can control the behavior of a virtual object in Unity with the help of sensors. So this is all from my part, and I will request Professor Homik to take over.
Thank you, Shabda. So at least the participants are getting a feel that how the AR and the VR systems they are developed. And this is not a very easy task to do it. Okay, and within this time frame, okay, sometimes it may not be possible also. So we have taken a very simple type of examples, and which the participants, even those who are listening this kind of technology, AR and the VR technology for the first time, they can also understand that what the technology behind it. Okay, and this is not a very easy task because your hard and soft both are combined together. Real and the imaginary. This is both the technology, real technology and the imaginary technology. They are also coming together. And how to handle this digital, analog, and then real and the virtual, everything in one platform. Okay, and this is really, it is a difficult one. But somehow we try to give you a like a flavor of the subjects. Okay, and what I can do, if some time permits, then I can just quickly go through some of the videos, more number of videos, or I can show some of the work that what we have performed. A little bit of work we are doing, that is AR and the VR is not our main area of research. Okay, so this is a kind of side activity we do in this particular area. Say for examples, just a minute, give me some time. I will set the systems. I have not set it properly. This is visible, I think.
Yes, Professor, it's visible.
Okay. Let me just play the system first. This is the camera unit that I was mentioning, and this is known as a Kinect-based camera unit. And the Kinect is connected with a small processor unit, and this is itself, it is a PC. The small portion that you are seeing over here, this is completely, it is a PC. Okay, but the size, you can imagine that what small size it has. And this is a platform, and this platform this is a platform on which this camera unit is placed. And this total platform, it can move from one location to the another locations. Okay, so what we like to do over here, that sometimes it's maybe sometimes it is necessary that we have the model of the total environment. Okay, so either it may be a realistic models, or that means a physical model, or it may be the CAD model. Okay, now if I have a physical model, so the real systems which we have, then from there I can also make the realistic model, okay, of the total environment. And for that purposes, this kind of camera units may be used. So you can see that there is a marker. So on the wall of this room, there are markers are there. So this is our laboratory where we are doing this kind of work. And these are the markers. And on the walls at the different locations, different shape markers are placed. And then from the marker, these camera units, okay, so whenever the camera will rotate, so it will have a look of 360 degree. Okay, so rotation is of 360 degree angle rotation is possible, and then it will grab the images. Okay, and step by step images it will capture it with respect to time, and after that it will stitch all these images, and then it will make the three-dimensional view of this complete room. So let us see this one. So whenever it is scanning, it takes a lot of images. The images are now processed, and then from all these images, the system is trying to build up the virtual model of this room, of this laboratory. So it will make a virtual model, but this virtual model has been created from the real objects. And this virtual model, once we have a virtual model, then what I can do, I can have a virtual robotic systems. Okay, and those who are interested, they can know, or those who have some ideas about this robotics, they know that a mobile robot can move from one location to the another locations. Now, what you can do, what the students can do, they can make a virtual objects, okay, virtual environment. They can do it. They can create it, and this virtual environment they are creating from the real objects, from the real environments, and then they can also make a virtual robots, and they can play the motion of a virtual robots. So, how a mobile virtual robots will move in a virtual environment. So they will make some sort of logic, okay. And the systems will the virtual systems will based upon this logic, and the students can see that the implications of their logic or implications of their algorithms through this virtual reality environment. So there is one applications area. You can see that this is a movie. pointing device, and through this pointing device, it is always means it is possible to point to a particular object and take the view of this particular object in a broader way. So this is known as a Google Earth VR systems, virtual reality systems. Okay, and somebody wants to see that the different portions of the Earth. So if I have a Earth model, then I can point out my device, pointing device, to a particular locations of the Earth, and I can see the each and everything's virtual models, each and every virtual objects at that particular locations. So that is possible also. Let us listen the technology, the level of technology in air.
Virtual reality and augmented reality. They kind of sound like something you need a drug counselor to get through, don't they? But in fact, they're the hottest two technologies going these days. Let's learn about them so we can compare and contrast what each of them does so they wow you instead of overwhelm.
So we can see that these are the devices, head mounting type of devices. Previously, it was a very costly. These items was very costly, and now these items becomes cheaper. So more and more people, that's why they are using this AR and the VR technology nowadays. Otherwise, previously 20 years back, this technology was there, but it was not an affordable items. Okay, to the researchers or to the engineers. Okay, so that's why the AR and the VR technology was not developed in that way.
Overwhelm you. Augmented reality is when you look at the real world, but it's augmented with additional information or graphics in your view. Now, key to this AR concept is that the things are indexed to a location. That means they occupy a relevant place in your view, as opposed to moving with your gaze as you turn your head. And in many cases, you can interact with those visuals that are augmenting your view. AR can be had via a phone and one of the many AR apps out there, or for higher performance, you use dedicated AR glasses. Know that AR is increasingly being referred to these days as MR, mixed reality. It's part marketing term and part acknowledgement of AR's ability to augment the real world while also bringing in unreal elements. Glasses that augment your view without being indexed to a location and space are better referred to as connected head-up displays. Now, Google Glass was the infamous standard bearer of that sector, but more recently, Vuzix has shown their pending Blade, an impressive set of head-mounted displays that include integration of Amazon Alexa to help you drive what's displayed via voice. Virtual reality is when the world you're standing in is replaced with a virtual one. With some of these, everything you see and everything you hear is replaced with something computer generated. Now, the world that takes you to can be very naturalistic, actually, or extremely synthetic and fantastic. VR, you're surrounded in 360 degrees and the space is three-dimensional. Now, in its most ambitious forms, VR places are also navigable, as you can move through them and use your hands to manipulate things within them. VR can be done as simply as sticking your phone in a literally cardboard head.
So this is the technology that's been said. Mobile phone is placed in a cardboard, and this was the first. It was demonstrated, okay, as a technology of AR and the VR. And the same technology now we are using the same technology, but in a sophisticated way.
Head mount, or a little more upgraded plastic holder. But the attention these days is mostly on real deal head-mounted displays. Until recently, these were quite cumbersome and always tethered to either a game console or a high-performance PC. But more recent versions acknowledge that tethering is going to be a non-starter for a lot of users, and instead the new headsets build the electronics into themselves or maybe into a small companion processor you wear on your belt for a pseudo-cordless experience. The bottom line on AR or VR is that you really have to experience it to understand it and appreciate it. It's very hard to read an article or look at a video like this and understand the impact of these. They aren't like a lot of other technologies. The good news is you've got plenty of time. Both of these are pretty green and have a long way to go before they hopefully merge into a pretty smooth continuum of abilities, whereas right now it can be a little hard for the average user to knit them together, let alone find a use case that makes sense to them.
So that is the level of AR and the VR technology. And maybe in the future, there will be no differences between the AR and the VR. We don't know that in which directions the technology will move. And generally the people, they are not distinguishing right now. They have all started, means individually they are not distinguishing that whether this is considered to be an AR systems or this should be considered as a VR systems. So something, maybe some exciting features of the AR and the VR technology it has not been discovered, or maybe it has not come into the means practical level so far. Okay, so we hope that this technology will grow further, and mostly in the academics sector, portions, we are not using this AR and the VR technology. Okay, so though we are understanding that this technology is essential and this is a good technology, but so far we cannot afford to have these AR and the VR systems in our curriculum. So if we can bring this technology, okay, these features, AR and the VR features in our academics, and mostly for the experimental purposes, some of the experiments, even we need not to do in the hardware setups, okay, and we can use this technology, AR and the VR technology, for teaching some of the experimentations, even in a better way we can do it with this technology. Okay, so that's all, and I don't have anything else, or I can show if time permits. Can I have some more time so that I can show you some
Yes, sir, yes, sir.
some more advanced means development in the field of AR and VR. Let us see this HoloLens video. Okay, it's a fantastic video.
Today, I get to show you something very special. It's something we've been looking forward to for many years. When we set out to build HoloLens 2, we wanted to create something that you didn't need to learn how to use. You should just know it. And we call this instinctual interaction. Let me show you. Now, as Alex mentioned, the HoloLens 2 is very comfortable. It fits just like a hat. And the only thing that's even more effortless is how I'm automatically signed in. With Windows Hello and our authentication, the HoloLens 2 is actually signing me in as I put on my device. Now, not only does the HoloLens 2 recognize me, it also recognizes my hands. Look at this. Fully articulated hand tracking. And as I move my hands around, the HoloLens 2 is actually calibrating to my unique hand size. And of course, not only does the HoloLens 2 recognize me and my hands, it also recognizes the world. Welcome to my mixed reality home. This is the place where I have all the apps and content that I use every day. Let's check some of them out. Now, I've seen many people put on HoloLens for the first time, and the first thing people do when they put on the device is they reach out their hands and try and touch the holograms. And now, you can. Look at the way that the hologram's responding to my hand, almost inviting me to touch it. And in fact, I can just grab this corner to resize it. Or I can rotate it, or move it. That's right. We are touching holograms. This is an app I've got called Spatial. Let me just put it right there. I've got another app here called Vuforia View. Now, it's a little big, so let me just use 2 hands here to make it smaller, and then rotate it so you can see. There we go. And then let me put it down here near Spatial, maybe make it a bit smaller. Yeah, that's nice. All right, now let's switch gears and talk about a different kind of application. I've got a browser over there, but it's kind of far away, and I don't really want to walk over there, so let me just call it over with my voice. Follow me. This is a browser that's running Microsoft Teams, which is a tool that we use back home to collaborate. Let me see what the team's been working on. Okay, it looks like they've got a surprise for me in the Playground app. I just have to say the words show surprise. All right, so let me just open up that start menu here, and then place the app, and then launch it. So now we're actually exiting my mixed reality home and going into an immersive experience. But notice that that browser that I had actually followed me in. Now this can actually be really useful when you have things like emails or PDFs that you need to reference while you're doing your work. I don't really want it following me around though while I'm showing you all this cool stuff, so let me just put it over here, and then we'll get back to it later. Welcome to the playground. We spent years exploring and refining interactions for HoloLens 2. And the playground is just a tiny sampling of the many prototypes that we built, tested, and learned from. Our approach is basically to try out as many things as we could and look for the things that stood out. So for example, here I've got 3 sliders. Each of them is controlling this wind farm simulation, but each in a different way, using a different interaction technique. One of the things we tried is this touch slider here. So here I can just stick my finger in the slider and have it go to a particular value to control that wind speed there.
So we can see that the hand movement, how it is connected with the audio. Okay, so it is creating the realistic audio. So whenever the switch is moved, like a slider is there, the slider is moved, or whenever the slider is placed, or say for example, the red color button is a kind of push button is there. So when the push button is placed, so there will be a voice, okay, sound has been generated. And this sound has been artificially, it has been generated. And whenever the lady will press that red button 1, or he's just sliding the different buttons, okay, so you just see the sound, you just listen, the sound that is created is related to the movement of the buttons, okay. And here also we will find that there is an harmonium, means is a kind of piano systems is there. So whenever the keys are pressed, okay, so whenever a particular key is pressed, at that time a particular sound will come out, and all this is artificially created. It is not that the sound is coming from the actual device. So the sound is basically coming from a virtual objects, okay. But what should be the sound? So that has been generated by the computer science people, those who have developed this kind of models. So along with these CAD models, they have also developed the sound systems, and this CAD model and the sound systems are combined together to generate the realistic impressions to the person who is playing all these devices. Let's play.
It felt okay. We also tried this push slider. So this guy can kind of nudge from side to side, kind of like an abacus, which was interesting. Now, the interaction that really took home the cake, though, was this pinch slider. The way that works is you just pinch it and move it wherever you want. And what we found was that people really like that tactile sensation of their fingers touching as they grabbed and then released. And across the board, for all interactions, the audio and visual feedback as you grab, move, and then release were all really critical for making this experience feel connected. Oh, this is just so satisfying. I can't wait for you all to try this out. All right, now let's move on to a different kind of control, buttons. How do you press buttons on HoloLens 2? Well, you just reach out and press them. Now, one interesting thing that we found about buttons was that the size of the buttons actually impacted the way that people interacted with them. So for example, for the smaller one, most people would use 1 or maybe 2 fingers, but for the larger one, pretty much everyone used their entire hand. And this is kind of interesting when you think about it, because these objects don't really weigh anything, they're just digital things, but despite that, people would treat them like real things, almost as if the bigger one had more weight. I just love the way these move and the sounds they play when I press them. It's great. All right, how about something that uses all 10 fingers? Well, to test that out, we built a piano. So here I can just play a chord, or I can play the keys one at a time. All right, so where's that surprise that the team had for me? Oh, that's right, I had to say those words. Show surprise. Ooh, look at that hummingbird over there, it's gorgeous. I wonder if it will fly to my hand. Yeah, oh wow, this is beautiful. I just love the way that it's following my hand around. I've got to tell the team, they've done a great job. And in fact, I don't even need to use my hands to do this because I can use my eyes and my voice. That's right, HoloLens 2 has eye tracking. So I can just look over to this browser here and look at the bottom of the screen to scroll it, and then send my message. Start dictation. The hummingbird looks great, exclamation mark. Send. So this is what we mean by instinctual interaction. By combining our hands, our eyes, and our voice, HoloLens 2 works in a more human way.
Today, companies tackling the world's biggest problems are increasingly spread across the world. And the
Hey everyone, it's great to be here, all here together in the same room.
Cool. Now, to show you how companies are using spatial to transform the way they work,
the similar kind of the similar kind of videos. Okay. I think I have not left anything like which needs to be further discussions. But this is a new subject, new area. We are also experiencing it. Okay. And people should have worked, more and more students should work in this particular area. But the good thing is that a lot of things are there. And technologically, this is also a very rich subject. Okay. And means it is not only the graphics or a kind of entertainment only, but along with that, there is a science, there is an engineering associated with it. Okay, so you can understand that a lot of transformations matrix are involved. Mathematics is also involved. So without this mathematics, actually, we cannot build up such type of system. So you must have a solid backgrounds, engineering backgrounds with the science, knowledge of the science, as well as you must have some sort of imaginary power, imaginary understanding. So with the help of these two, only it is possible to penetrate into this particular area. So thanks to the organizers for giving me an opportunity, and I hope that you found a little bit of informations maybe from our lectures, from our discussions, from this audio, from this video, and from the demonstrations. I think we tried our best, okay, to provide you a little bit of information on this particular area. And I hope that other experts also, they are providing a lot of information, a lot of input in this particular area, and people will find it more and more interesting, so that at least there will be no shortage of manpower who can develop here in the VR systems. Thank you.
Dear participants and faculty friends, do you have any more questions? I hope this session is very nice. I take it as positive. There is no questionnaire in this session. Dear Professor Subhasis Bhaumik sir, thank you very much for your valuable time, and the content delivered in this session is very much informative, useful, and interesting. And especially to your PhD scholar success sir, your hands-on training in AR and VR technology using Euphoria tool, and how to incorporate Arduino IDE with Unity 3D. That session is also very much useful and very much interesting. So once again, I thank to Professor Subhasis Bhaumik sir and Saptak sir. So in future also we will collaborate with you for many projects like seminar, workshops, and conferences. Thank you, sir.
Thank you. Thank you. Thanks to all the participants for patiently hearing our talk.
Thank you, sir.
Yes, sir.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Okay.
Thank you. Dear participants and the faculty friends, the third day afternoon session is over. I hope you have completed your feedback forms. Please complete the feedback forms. If you have any discrepancies in that, please let me know so that we will do needful for you. And also tomorrow session, 2 more days is there for this ATAL AICTE-ATAL program is there. So we will meet on tomorrow. Thanks once again to all. Thank you very much. Alexa, thank you.
Thank you, Martin, sir. Thank you.
Thank you.